welcome to our second day of the Mineralization Summit. To both of you, of course, online and in Harpa. My name is Vala Jónsdóttir, and I am lucky to be a part of the Carbfix team and very excited to be here today. Ole covered the practical considerations well yesterday, except for the toilets maybe. So a brief reminder, when you exit this room, you take 2 lefts and then 1 right. Today we will have a short break at 10:45. Lunch will be served at 1 o'clock. And at 3 o'clock, we'll ask you to come in front of Harpa for the field trip. So I think that covers the practical considerations. Sorry. I have to start by asking, did you see the Northern Lights yesterday? Yes. Sorry to those online. It was very amazing. You'll have to join at a later time. Today we will have 2 keynotes. We have 3 panel discussions. And I am sure that we will all go home very inspired, perhaps learned a thing or 2, continuing our journey on doing everything, everywhere, all at once. So without further ado, let me introduce Juerg from 4401 with his keynote to start the day. Welcome.
Thank you very much, and a big thank you, to the organizers. I'm so happy to be back. My last time here at the end of Carbfix 1, which I was part of it, that was in 2016. And now, a few years later, we are here, and we have the opportunity, to discuss very important things with regard, to CO2 mineralization. And, I was tasked to give kind of an overview of mineralization as a global solution. And we heard a little bit yesterday, about where we are, And it is really a journey to scale, and we have to scale. And so it is basically important to discuss what kind of the challenges are there to scale up. And, where are we, kind of come up with an inventory and say that's the status quo right now. But what do we have to do to really, get to a gigaton scale? So I will give a short, overview of mineralization approaches. There is not only, there are different pathways for mineralization, and I will summarize a little bit, what these pathways are. I will then, discuss mineral resources. We all, for carbon mineralization, we depend on the availability of reactive minerals, that convert CO2 permanently to calcium, magnesium, iron carbonates. I will then discuss and address a bit, technological challenges. Technological challenges for the different carbon mineralization pathways, but with really a focus on in-situ mineral carbonation. Then, what are the socio-economic challenges? I will just, touch on them because we have following up talks on policy and panels on policy, but this is kind of an introduction into, the socio-economic challenges. And some of them were also addressed already yesterday. And then, I give some personal recommendation, what I would like to see in that field. And as Klaus mentioned yesterday, I started research in carbon mineralization, in 2001, when I moved to New York City and did the first test in the Palisade sill, which is kind of a dolerite basaltic formation. So for me, very long time now, I'm working on this topic. But if we look at mineralization as a global solution, there is not only one pathway. There are different pathways. We heard from Greg yesterday about mineral carbonation of mine tailings. So there is an ex-situ, or there are ex-situ pathways, there are in-situ pathways. And in the ex-situ, we have carbonation of mineral waste. There is a lot of mineral waste around. This is kind of a long-hanging fruit, that is ready, to be implemented on larger scale. As we heard yesterday, there is something called enhanced rock weathering. I will focus a little bit, on spreading reactive minerals on croplands for alkalinity production through enhanced weathering. And then something I barely touch on, is calcium magnesium oxide looping, because that's more kind of a capture system. They depend obviously on storage or utilization, because they capture through a mineral gas process the CO2. No? And then in situ, obviously we heard a lot yesterday about in situ mineral carbonation in basaltic, in mafic rocks. We have a perfect, absolutely amazing example here, and we will see later this afternoon on our field trip more about this. I'm, moved on. I'm working on subsurface mineralization in peridotite now. So I'm part-time at the University of Southampton. I'm the subsurface lead of 4401. And, both can be done on and offshore, okay? These are the two options. We can do things offshore, onshore, in ultramafic rocks as well as in mafic rocks. And then there are, subsurface mineralization in other igneous rocks. It's not just, basalt or peridotite, or, as the Japanese demonstrated a few years ago, volcanoclastic rocks, They are highly reactive, and they can be utilized for in situ mineralization. But where are we? Where are we now? No, we heard yesterday from Klaus, and Klaus and I collaborated for a long time. We heard about, Klaus and Seyfried proposed basically a carbon mineralization as a CO2 removal technology 1990 and 1995. We are now, in 2023. Where are we, We have an in situ mineralization in basalt. If we go to the Carbfix website, 95,000 metric tons were injected since 2014. Fantastic. No? We have, we did a very, small test in peridotite, 1.2 tons of CO2. This is a pilot test to then, learn a lot how reactive are these peridotites. Can we scale up, to larger scales, which we are working on right now. With 44.01. Ex situ mineralization, mineral waste carbonation, we heard from Greg, there is a passive carbonation of mine tailings, and that's roughly, if we take the example of the Mount Keith, Greg told us yesterday, 40 kilotons of CO2 per year, passively absorbed, converted, to carbonate minerals by CO2, water, and mine tailings reaction. And then, there is also an active ex situ mineralization part, and, we are here to learn. Until yesterday, I had no idea, on which scale we are there, but Greg just demonstrated to us that we are on the 1 million to 2 million ton scale if we activate, the mineral waste and actively then carbonate it. So it has to be activated, to get on that 1 million, 2 million ton scale. Enhanced rock weathering, there are many companies now active in that field. That's basically, spreading crushed basalt, in croplands, enhancing, the CO2 uptake in the soil, through weathering of the basalt dust, and producing that alkalinity, which basically then binds CO2. If we go, to one of the UK centres, Leverhulme Centre for Climate Change Mitigation, they really focus on, enhanced weathering in croplands. They claim roughly right now 30,000 tons of CO2 per year is basically is the uptake through enhanced weathering projects right now globally. And then, if we look at the natural rock weathering process, which is very, relatively slow, but the globe is big, that's 1 gigaton of CO2 per year. But that's kind of the status quo there. And it's clear we have to scale up now. And we have to scale up rapidly to really have, an impact on climate mitigation. And now, I will just discuss a little bit, what are the scale of the available resources. Here, you can see kind of a global map, and you can see, these dots. The bigger the dot is, the more, gigatons of CO2, or the capacity for CO2 mineralization is indicated by these dots. You can see in dark blue, these are mafic rock, basalts, and in green are ultramafic rocks. But there's a global distribution of these rocks. And, we have the resources as indicated here, potential capacity, and Siggy was absolutely right yesterday, saying, these are kind of theoretical capacities. It doesn't mean that we can really mobilize all that capacity, but it's big. That's the message. It is really big, but these estimates, most of these estimates do not really include, reaction kinetics, because we do not have the data for all, all the kinetic data, and, reservoir parameters. And if we look at this global distribution, we have one active project in basalt right now in mafic rocks, and that's here in Iceland. No? And we have a lot of data here in Iceland. We have a lot of reservoir data here in Iceland, but for many, many, locations here, we do not know how the reservoir looks like. What is the permeability? What is the effective porosity? What is the reactivity? So there is a lot of exploration has to happen to actually scale up to that scale indicated here. So exploration, is a big part. Then, if we look at the mineral waste, alkalinity sources, there are different sources. There are fly ash, cement, kiln dust, steel slag was mentioned yesterday. So these are industrial alkalinity sources, huge, and then we have all the mine tailings, and Greg just showed us some of the examples, where they can use. Again, global, availability of these resources. So we are not resource limited, okay? That is an important point. 2 to 9 gigatons per year capacity. This is a wide range, but we did a study, for example, for mine waste. One of my postdocs did that, and what you can see here on this graph is the CDR potential, so the carbon dioxide removal potential by alkalinity generation in kilograms of CO2 per ton for different mining operations, different commodities, and you can see here, kind of the contours, tell you how many tons of CO2 per year, you can basically remove. And, we have some mines, as Greg mentioned, like nickel sulfide obviously have a very high potential, CDR potential, because, they have these alkaline earth metals we need for the carbonation. But generally, if we just look, at the CDR potential as a function of estimated tailing productions, and this is all, published data from mining industry, you can see that we have kind of a theoretical CDR potential between 1.1 to 4.5 gigatons per year in the mine waste pathway. If we then add, Liam just went a step further, with colleagues at Oxford, and included existing reaction kinetic data of, this mine waste into this calculation. And obviously, if we look at the actual reaction kinetics without, really accelerating, through an engineered way, the reaction kinetics, the potential is smaller, but it's still in the hundreds of million tons per year, which I think is generally a good news. And then, if we look at enhanced weathering in agricultural soil, if we take, the potential capacity is roughly around 1 to 2 gigatons per year. If, we take 10 to 50% of available cropland, no? And we are using basalt. And, the potential capacity could be much larger, if we look at the available cultural, agricultural land in warm and temperate areas, regions, and using dunite, no? Dunite is not really, is ultramafic rock, but, the total, volume of dunite available is not really, huge, but so I would, again, this is a theoretical value, and we have to be very careful, to use these values. But we are in the gigaton scale too, If we can engineer that and we can apply it, kind of globally, obviously in areas that are, warmer climates, warm, humid, tropical climates, weathering is much faster than in temperate ones. And then this is looping. I will go, very fast over this because I think, it is just an add-on. But really, if we do, use calcium or magnesium carbonates in a looping system, to capture CO2, it is a capture process. And, basically, we need that process needs, a storage or a utilization combined with it because it is a pure capture process. So right now, less of an interest for today's discussion. But let's move on, to the challenges. And I think, one of the biggest challenges is water, no? Because if we think about, what we want to do in this carbonation reaction, for carbonating these minerals, and this is our magnesium, calcium, silicate-rich minerals, we need water. So there are two options to do in situ, for example, in situ CO2 mineralization by pumping CO2 into, a reactive rock reservoir. We can inject, supercritical CO2. There, obviously, we have the challenge of buoyancy. So that's similar, to conventional carbon storage, in sedimentary reservoirs. Supercritical CO2 is buoyant. So we need a cap rock. Otherwise, CO2 will rise up, and there is the risk of leakage, and will be less permanent. Geography obviously plays a role. Where do we have ultra-mafic and mafic rocks that have actually a cap rock? We, do not really know that globally. Where are? We know that, Columbia River basalt, and Todd mentioned that, has that, has the capability of supercritical CO2 injection. Sella, with Claire Nelson, they do a supercritical or plan a supercritical test in Kenya. We have that. The site allows, the reservoir has a cap rock, so it allows supercritical CO2 injection. But then, there are big questions about reactivity, and how fast reacts supercritical CO2, reacts with the rock. A lot of work is going on, but on the reservoir scale, we have not really resolved that, I think. And then the retention time, that really depends on the reaction kinetics, how fast that supercritical CO2 is, the retention is of supercritical CO2 in a reservoir, because it's buoyant. So is the buoyancy much faster than, the reaction? Is the cap, does it go up to the cap rock? These are open questions. Dissolved CO2 injection, that's what Carbfix is doing here. That's what we are doing, in peridotite. So the CO2 to water ratio is absolutely critical. Not every region, is that fortunate like Iceland, and has the water. Yes, there is seawater, if we are at the coast, we can use seawater in the process, which opens a lot of, challenges too and questions. So I think one of the biggest, one of the big problems we have to address is CO2 to water ratio. The quantity of, water will require more injection well, depending on the injectivity of your reservoir, But generally, I think, we will need more injection wells. The storage capacity has limitations based, due to the available pore space. And I will do it back on the envelope calculations in a minute. And then corrosion. So if we go, for example, with seawater and CO2, we dissolve CO2 in seawater, inject that. This is one of the most corrosive fluid you can imagine, And so there's material challenges, huge material challenges. We can, they're solvable, but they come with a cost right now, and a huge cost, I can tell you that, based on experience. So, mineralization, generally, it's a fluid CO2 rock reaction, requires water. It can be seawater, can be fresh water, can be grey water, can be processed water, like Talal, my colleague, mentioned yesterday. In arid areas, we have, for example, in Oman, we have a lot of processed water, which could be used. But what are the reactivities? What are the solubilities of CO2 in processed water, in grey water, etc.? We still, that data has to be generated. The CO2 to water ratio is a function of CO2 solubility, obviously, and that depends on pressure, temperature, and salinity of the water. And Siggy just discussed that yesterday. He showed a curve that's very similar to this one. This one here is just, at 60 degrees Celsius. What you showed was, at 25 degrees Celsius. So temperature has an effect. And so if the reservoir temperature is much higher, then the solubility of CO2 decreases. But roughly, if we take, 600 meters depth, so we inject CO2 or dissolve CO2 at 60 bars, the ratio is 1 to 23. 1 ton of CO2, 23 tons of water. Okay? So the solubility increases with injection depth because we have increasing pressure the deeper we go in a reservoir, and CO2 to water ratio also increases with increasing injection depth, obviously because the pressure is increasing. Okay? So if we do a kind of a very simple back on the envelope calculation, I take 1 million ton of CO2 per year, inject that for 10 years into reservoir. I do that at 60 atmosphere. So I dissolve CO2 at 60 atmosphere. The ratio is 1 to 20. Works for me, no? And I take the peridotite in Oman, no, which is 21,000 cubic kilometers of rock. I say, and that's an assumption, no, 1% is available pore space. Is the effective porosity is 1% in a large reservoir. And I take this 1%, and then I see the volume, the usable volume, pore volume in that rock, is 10 to the 11th cubic meters. And that's, the volume of water in 10 years for, 10 million tons. So you can see, yes, if I assume a 1% very conservative value for the available pore space, it is possible, but we are coming quite close, to the available pore space. So that's kind of the challenge for each reservoir. We have to figure out what is the available pore space and can we actually scale up to a 1 million ton per year, Similar here, Grand Ronde and Todd can challenge me here, but this is a, kind of an estimate of the volume and obviously, 1% usable pore space. That is basically, the cubic meters of pore space available, compared to, the volumes we have to inject over 10 years. The message here is just, it is a challenge, but, 1% is very conservative. In Iceland, there are effective porosities of up to, 8%. We had, measured in, or even higher, Sandra says, maybe higher. So that is good, So that is really good news. But not everywhere we have, 10% available pore space, So that's what we really have to figure out. Then, for scaling up, I think hydraulic, chemical, mechanical feedbacks are absolutely important. And this is, basic research. And this is still, kind of in a basic research state. What our goal is, is to maximize CO2 injection rate per borehole, We want to run a business out of it. Sustained injection and fluid flow rates in the reservoir. So we need sustained long-term injection rates. And, we need sustained and fast reactions. So dissolution as well as precipitation has to be rapid. And so the controlling processes, what really, a lot of research is going on is understand, the hydraulic, chemical, mechanical feedbacks. And I will address that a little bit in the next slide. The relationship, porosity, permeability, and reactive surface area. We might know and have some data, here in Iceland. But in other places, that global map I showed you, we have to do that. We don't really know. Coupling of dissolution and precipitation reactions. So how does that coupling work? Where is dissolution happening? Where is precipitation happening? Under which conditions? Location of dissolution and precipitation reactions. Siggy nicely demonstrated that obviously around the injector the fluid is a pH of 3, or 3.5. And then we move far field, pH is more neutral towards alkaline in this type of rock, and precipitation occurs. So where precipitation occurs, we have to monitor that now. So that's a challenge I will discuss, for monitoring. Then self-accelerating versus decelerating volume increasing reactions, maybe less important here, in Iceland, but very important for our case in peridotite. No? And the time scale of the different processes, basically unknown. No? So what do I mean with self-accelerating and decelerating processes? This is basically illustrated here. If we convert an olivine-rich rock, olivine is a higher density mineral, to a lower density carbonate mineral, the density, there's a huge density change. There's a volume change, and that volume change in the subsurface induces a stress on the rock. And that stress, is actually high enough to crack the rock. No? And that's when, Peter Kellerman and I, basically revived the idea of reaction-driven cracking. So if we have, a front of carbonation happening, we have that volume increase happening, then basically it could reach a self-accelerating regime where, you crack the rock while it is carbonated, producing more reactive surface area and therefore more reaction. No? So that is a self-accelerating one. You can think about the opposite, you clog up the pore space. So when are we, in a reaction-driven cracking regime, or when are we in a clogging regime? We don't know. We know from laboratory experiments, like illustrated here, which I will discuss in a few seconds, but we don't really know on a large reservoir scale. No? So we have to do a lot of research on that. So what this plot shows, it was published by Uno, Japanese colleagues. It shows the log of, basically the fluid flow rate, no? And it shows the reaction rate here. And, volume increasing reaction in the laboratory, resulted in increase of permeability under, a confining pressure. Oh, already? I'm over time. So I have to speed up. So ratio of fluid flow to reaction rate is really important. That's the primary control, no? So that ratio of fluid flow to reaction rate is a control if we get into the self-accelerating regime, which is basically down here, which was demonstrated, by natural peridotite carbonation examples and by laboratory experiments with brucite. So where we are on that diagram is very important now. And then, Sigi basically addressed that a lot. It is the reaction kinetics. It is a cross-cutting technical challenge. It's a technical challenge for enhanced weathering. It's a technical challenge, as we know, from mine waste carbonation. So we have to think about, for scale-up, how we can accelerate, that reaction, these reaction rates, no? And then, I skip over this, because of time, but there is land use challenges, especially in ex-situ mineral carbonation and especially enhanced weathering. Land use, is obviously a challenge. And you can see here some, estimates of how much land is required, for the gigaton scale. But because we had that discussion a little bit about monitoring verification and for me also measurement, this is a cross-cutting technical challenge. Again, take ex-situ mineral carbonation, no? Enhanced weathering. These are open systems, no? Open systems, monitoring open systems is absolutely, a huge technical challenge, how to do that. If the alkalinity from the copland is exported, into the oceans by rivers finally, first gets into the groundwater, then into rivers, and then into the sea, how do we monitor that, no? I think it is this huge open question. And then, how do we distinguish natural mineralization, from engineered mineralization, even in reservoirs, no? And I think, the direct and indirect monitoring of mineralization, is complex. And we cannot rely like we did in Carbfix 1, where fabulous technicians went out every day and then every few days, if there was 2 meters in snow or, rainfall or to collect a sample for us, no? We can't. So we have to think about new monitoring measurements like new sensing, new computational techniques, and that was mentioned a little bit yesterday in the panel. And, do not forget, we are dealing with a multi-system monitoring. So we have to monitor atmosphere, surface, soil, shallow subsurface, reservoir now, to really then get quantitative data to see how much of the CO2 is mineralized as a function of time, and was there any leakage out of our storage complex. I think this is a lot of really innovative things are happening in this field. In the next couple of years, it will be exciting to see how we monitor on a large scale. So this is a summary which I do not, because I will get stopped very soon, cut off. But this is kind of the major I think challenges. Is we have to constrain better the reaction rates. We have to do a lot of exploration globally, to see where are the best places for mineral carbonation. We really have to understand these chemomechanical feedbacks, better. Socioeconomic challenges, and I was actually very happy to hear yesterday, from representatives from the EU, from ambassador, and also, from the Prime Minister here, that things are changing, which is really good news. But, generally, there are different applicability and feasibility, for carbon mineralization in different locations, It's different. It's not one recipe for everywhere, So we have to adapt, to site-specific parameters. Policy frameworks, governing carbon mineralizations are unclear, and I think they're still unclear. And they're posing an impediment, for our upscaling of the process. Think about, existing country-specific laws, regulations, and requirements have been formulated not, for carbon mineralization, but generally, for geologic storage in sedimentary reservoir. I take the EPA Class 6 well, permit. It's not fit for purpose for mineralization. And it's good to hear that things are changing. If you talk to EPA, things are changing. And they are required, for our upscaling. The other one, good news, this is old message now, the CCS directive from the EU, was not really, it included explicitly carbon mineralization. It does now, so there's work in progress, which is really good to hear. And, if we think about offshore, there is a lack of regulation in international agreements, on offshore carbon mineralization. So these are kind of the challenges. So, also, I think an important part, for existing methodologies for life cycle and techno-economic analysis, they differ. You do it differently than we do it, so we can't really compare. And we need kind of, process models that are comparable, So we have to use kind of a similar approach. And that is also, I think a very important part. And finally, there are uncertainties regarding, eligibility of carbon mineralization for statutory incentive programs. Carbon mineralization is not specifically included there. You can correct me, if it's included in, for example, the 45Q. MRV requirements and provisions in existing incentive programs, are not inclusive or specific for carbon mineralization. We have to change that, otherwise it's an impediment for our scale-up. And we need standardized MRV methodologies and protocols for carbon mineralization, and work is in progress, for example, through CCS+, which is really good. So we will compare apple to apple and not apple to bananas now. And so these are the major conclusions, but I skip because of time issues and come up with some recommendations now. I think really important, and it's demonstrated by Carbfix, it's demonstrated by 4401, we have to leverage of existing industries. Wherever we operate, we have to leverage and collaborate with existing industries. That is geothermal here, for the Iceland case. It is mining, for other places like where Greg works, and, for us in the Gulf region, it's leverage with, oil and gas industry. Very important, That allows fast learning because, we combine knowledge together. And then absolutely crucial, And looking at the map of active field and demonstration projects, we need a lot more of these projects globally. So it's very important, that we rapidly, scale up on field pilots, demonstration projects. Maybe, like it was mentioned a little bit yesterday, mineralization hubs. We talk about there are DAC hubs in the United States. Maybe we need a lot of, mineralization hubs. Combine, the efforts. That will allow us to scale up and implement large-scale deployment. We need international agreements and collaboration, on these demonstration projects, I think. Development of MRV frameworks, protocols. Good, we go in the right direction with CCS+. We need, TEA and LCA processing tools and standards. And finally, I think, I'm a researcher, I think collaboration on research and scientific and technical exchange, is very important. That's how we learn now, through exchange. And something like this summit, allows us to exchange our experiences and, some of our ideas. And I think that is very important for the scale-up of carbon mineralization. Thank you.
Thank you very much, Juerg. I think for the interest of time, we will skip the questions for now, but do use the coffee break to network and ask Juerg the questions that you might have.
Thank you. It was not my intention, to allow you not asking questions.
No problem, no problem. So next, I would like to invite Casie Davidson from PNNL to talk to us about a policy perspective on in-situ mineralization in the US. Welcome, Casie.
Thank you very much. All right, so I'm gonna skip through most of the preliminaries. I think I know many of the people in this room. Those of you who I haven't met yet, hopefully we get a chance to talk. But my name is Casie Davidson. I'm a researcher at the Pacific Northwest National Laboratory in Washington State, in the United States. I've been a researcher at PNNL for over 20 years now, and have been involved in mineralization storage for a very long time. There was a lag there for a while, and thanks to Darren Damiani, who I think is somewhere in the audience, we had couch cushion money to continue this research. So I'm going to talk to you a little bit about the research, but try to focus on the U.S. policy perspective in particular. I think there's a lot of uncertainties. We just heard Juerg's talk about Class 6 permitting. I think there are varying opinions. EPA is working on it. They are trying to incorporate mineralization into their thinking. I think there is language in Class 6 that nods to mineralization, even back when that was being promulgated 10 or 15 years ago. So it's been considered, but we'll talk a little bit more about where we're going. All right, so this is supposed to be a policy talk. I know a lot of the people in the audience are not scientists, and there's been a lot of geochemistry and a lot of very nerdy, geeky. I love the geeky stuff, but I think sometimes it can be a little overwhelming. So what we're really talking about when we're talking about mineralization of CO2 in these systems, you have three basic ingredients, sort of like making bread, right? The number of ingredients that you have to put into it are relatively limited. It's a simple recipe, but there are a lot of ways to make it and a lot of ways to get it right. So here we're talking about CO2, water, and cations. And in the cases that we're going to be talking about, we're talking divalent cations, calcium, iron, magnesium, manganese, those sorts of things. All right, so here's the geeky slide. Just kind of to give a broad perspective, I'm going to be talking a lot about basalts. We've heard a lot about basalts. We're going to see basalts this afternoon, and I am so excited to get to go to the field site finally after seeing pictures and being teased with other people's field trip stories for years and years and years. But as we just heard, it's the opportunities for reservoir rocks that provide those cations that you need. are varied, and we can be talking about periddotites, we can be talking about mafic rocks, we can be talking about mine tailings when we're speaking of mineralization. So those three basic ingredients are still what you're looking at. Basalt geochemistry, there's already been a lot of kind of deluge of geochemistry, and my colleague Todd Schaaf is in the audience, and if you love geochemistry, I thoroughly invite you to geek out with Todd. He loves nothing more in the whole world than to do that, so I'm not going to go into this. But in general, one of those key drivers for doing mineralization storage is being able to get access to those cations. In some cases, they're just floating around in the water in these reservoirs. In many cases, you're leaching them out of the host rock, and depending on the phase that you're trying to pull those cations out of, some of them are more stable and some are less. And glass is particularly easy to dissolve. It doesn't have a strong crystal structure, so you can break that down. And typically when we're talking about basalt storage, particularly in the Columbia River Basalt Group, we're talking about that glass phase as a key driver of reactions. Oh, and of course I would be remiss if I didn't give a nod to our really cool false color SEM image showing some of these carbonates that precipitated, and this is, I'll talk a little bit more about the Wallula project in a moment, but these are our anchorite nodules that precipitated. This is isotopically distinct carbonate material that did incorporate the CO2 that we injected, which was anthropogenic CO2. So we're able to prove that through that isotopic analysis. So one of the questions that I get often, people will call and say, hey, you guys are the basalt people, right? Can we talk to you about that? We've researched Carbfix, and they have one method, and your PNNL has a different method. Why is your method better than Carbfix's? And first of all, we love Carbfix, right? It just so happens that, and this doesn't happen often in science, where the two examples that you have that exist in the literature that have actually been demonstrated in the field happen to be these two end members of a system with a lot of different potential application spaces in the middle. So at Wallula, we injected supercritical CO2 into a basalt. There was already water in the basalt, so we had the CO2 piece and the water piece and the cations available from primarily the glass phase in that basalt, and we saw mineralization at the Carbfix process and at the site that we're going to see today. That is aqueous CO2 that's being injected. So you have your CO2 and you have your water, and you've mixed them together and you've dissolved the CO2 in the water before you put it in the ground or as you put it in the ground. But again, you have the cations and you have the CO2 and you have the water. So you have all of your ingredients to bake bread. There are some puts and takes, right? So we've heard about water requirements. As we start to talk about the regulatory framework in the United States, one of the challenges that you have with the Class 6 permit, which is the law of the land, if you're going to inject CO2 in the ground for geologic storage, you're going to be permitting under Class 6. We'll talk about that in a few minutes. But part of the Class 6 permit is this thing called area of review. And it is where your CO2 is and where your pressure plume is. So the more stuff you're injecting, even if it is in a less buoyant phase, it's still your pressure increase is still there, and you still have your CO2 over a wider area. So if you're injecting 25 times the mass under an aqueous injection scenario versus a supercritical injection scenario, you're going to have a larger area of review from that perspective. And I don't give that as like, this one's better and this one's worse. I give that as, these are the two end members. And there are a lot of variations that exist between the two, so that we can still provide that water to drive the reaction. We can still get the CO2 into the reservoir, but now we're optimizing on that area of review, which is a big cost driver. All right, so a little bit about the Wooloola project. This is the other one, neither better nor worse, although it was, it was a long while ago. This was a research project, as opposed to the Carbfix projects, which are commercial projects at this point. So the Wooloola project, this is our basalt, which is near and dear to my heart, Columbia River flood basalts, which you've been hearing about here and there throughout the meeting. This is a place called Palouse Falls, and you can go out there and hike or just drive up and take pictures. And this is a surface expression of our continental flood basalts that we have in the Northwest, and is typical of other flood basalts, provinces that you're going to see onshore in like the Deccan traps in India. I like to show this, and again, like for the scientists in the room, you guys already know this, but for people who don't eat, breathe, and sleep this stuff, the basalts that you see on the wall of this canyon, you see these, the white bars correspond to the low permeability flow interiors. And you know that they're low, I haven't gone out there and measured all of them, but I know from this picture that they're flow interiors because they're very resistant to weathering. All of that basalt is packed together really closely. And the areas in between that are these yellow bars are your high permeability interflow zones. And you know that because you see grass there. You see this kind of rubbly, it's all broken up, and there's water moving through it, and enough soil has been created, and you have water in that place that you can grow grass. You're not seeing grass on those flat cliff sides. So these are our aquifer aquitard systems, and just to give you a sense, this canyon from the surface of the river to the top of that bluff is about 115 meters. Getting people to think in terms of supercritical conditions and the depths that are needed for those, 800 meters is just not, it's not a depth that most people can wrestle with in their head. So that's the equivalent of 7 Palouse canyons stacked on top of each other before you even get to the conditions where you can maintain that supercritical CO2. And at the thickest part of this particular continental flood province, we're looking at about 4,500 meters of basalt total. So in 2008, we began a project at the Wooloola site, which is a drivable distance from here, and injected at about 830 meters. So we went in, did a characterization. We had a Class 5 permit. Class 6 did not exist yet, and we'll get to, for those of you who are not ready to take the quiz on all of your UIC permit classes, that's fine. You'll get a rundown of that in a couple of minutes. But Class 6 hadn't been invented at this point. It was still in the works. So this was permitted as an experimental well. We went in and injected 1,000 tons of CO2 that was sourced from a refinery in the region, and injected that over about 3 weeks. Came back in 2 years and did some sidewall coring, pressure testing, and wireline logging to try to understand what had happened in those 2 years that the reservoir was shut in. And that's where we started seeing these nodules that had appeared and understanding what they were and where they came from. So if they were, we're just dissolving carbonates and reprecipitating them someplace else, that would be useful to know. Or if we're taking the CO2 that was injected and turning that into minerals, that was also really important to understand. So that's where that isotopic analysis came from. We did see the isotopic signature of the CO2 that we put in from the refinery. So we know that that CO2 that we injected is in these anchorite nodules. So when we started Wallula, again, it was a really cool experiment, and we're still very, very grateful to the U.S. Department of Energy for funding this, for taking some cool lab stuff that we were doing and some other things that were happening at about the same time elsewhere in the world, and saying, okay, yeah, we'll give you a chance to prove it out and see if it works at scale in the field. And we learned a lot. So we understand now the reaction rates were actually a little bit faster than we saw in the lab, which is crazy to me. Usually it's the other way by far, where what you see in the lab far outstrips the reality in the field. We do know that we're not just dissolving and reprecipitating carbonates that were already in the reservoir when we started. We did not see significant, it was only 1,000 tons, right? So we didn't see any change in porosity that could be discerned in the before and after logs. And when we went back in and did hydraulic testing 2 years in after we had done the injection, we saw pressure signatures that corresponded with what we were seeing in these sidewall cores and in our fluid chemistry that confirmed that about 60% of the CO2 that we had injected 2 years earlier had been converted into mineral form. So extrapolating that out, our model suggests that right now, as we're talking 10 years after that injection, better than 90% of it is now a rock. And Todd talked a little bit yesterday about that micrograph that you see where, this is 16 million years old, and this is 10 years old now. And of that 10 years, right, like 8 of it has been sitting on this thin section slide. It was only in the ground for 2 years before we took that out. So we've learned a lot. It's been a very cool opportunity to prove something out in a rapid time frame. The project was ended in 2015, so we plugged and abandoned the well. If anybody wants to to pay us to re-enter that well, we would love to, or drill another well. The well is cemented to depth. But there's a great pressure vessel experiment that's been going on for the last 8 years, and we'd like to understand what that looks like. But the questions that it raised were even greater. So understanding how the injection impacts the reactivity and the reservoir parameters themselves beyond the wellbore. We get a lot of questions about, are you reducing your permeability? We didn't see that. We didn't see reductions in permeability or porosity, but again, these were relatively small volumes that stayed close to the wellbore itself. Understanding what, as you're moving CO2 into the reservoir, you're picking up water, so you're wetting that supercritical CO2 phase and making it very reactive. But as you're moving the CO2 through, you're desiccating the reservoir in your fast flow pathways, which is probably good. It's probably what you want to do because it's going to reduce your precipitation in those areas and probably reduce your dissolution as well because you don't have water to drive that dissolution reaction. So where in the reservoir are those reactions happening? Are they only happening at the margin of the plume, or are you getting these residual kind of fingering effects where if you think of the fast flow pathways as the main channel of the river, are there little eddies around it where you're seeing that carbonate precipitation happening? And understanding the processes that are driving that in the laboratory to help inform the reservoir modeling that needs to be done. The reservoir models to do this don't exist. There are some proto models. We've done work in Stomp CO2. This work was done in Stomp CO2, but that was for this site. There are lots of basalt chemistries. There are lots of variability in how much glass you have versus how much crystalline phase you have in these reservoir rocks, and in different from flow to flow and from different parts of your interflow zone. So how do we parameterize those into the models, and how much of that actually matters, right? Like, we don't want to polish the penny on that for too long. How do you optimize for long-term sustainability of the reservoir? This is a thing that you think about in geothermal reservoirs all the time, where you don't want to produce as fast as you can, because then you're going to deplete it too quickly and you might not optimize for your long-term output. Same thing could be the case here, likely is the case here. How do we do that optimization? How do we safely and efficiently permit in-situ mineralization storage? I hear a lot of comments like, oh yeah, Class 6 isn't going to work. It's not, I think actually Juerg made the comment that it's not fit for purpose. It is the law of the land in the United States. So, and it is fit for purpose for CO2 storage when we talk a little bit in a minute about what the purpose of that underground injection control program is. So understanding how do we do characterization, how do we monitor. In the Permian Basin, you can go out and shoot seismic. Basalts do not lend themselves to the same kind of resolution and the same kind of value from your seismic surveys. So the work that we did at Wallula to look at pressure and try to reconcile that with the modeling that we had, with the chemistry that we were seeing, with the precipitates that we were able to sample in the reservoir, is that good enough? Along with all of your typical pressure monitoring, things like that. RDD&D that's going on in the United States right now is really driven by what we learned at Wallula and the questions that we're getting from EPA around Class 6. How do we identify those gaps and then close them as rapidly as possible? We know there's a lot of demand to do this. I take calls, Todd takes calls at least once a week from people who are like, all right, we want to drill a well and get a Class 6 permit within 12 months or 24 months or something else that, you know, given the timeline for Class 6 in the United States, it's all pretty unbelievably aggressive. So how do we create the science that's needed to be able to inform that? So again, you know, this idea that basalts convert CO2 to solid minerals, and once it's mineralized, it's permanently stored. We heard a lot of that yesterday. That permanent storage, no risk of leakage, that is really appealing from a risk perspective. But being able to comply with regulatory guidelines is really important. So the Safe Drinking Water Act of 1974, which is probably before most of us were born, includes this clause that no owner or operator shall construct, operate, maintain, convert, plug, abandon, or conduct any other injection activity in a manner that allows the movement of fluid containing any contaminant into underground sources of drinking water, with, you know, some additional provisos there. This is the goal. It's not, the Safe Drinking Water Act is not about preventing CO2 from getting to the atmosphere. You're storing CO2 in the ground. If it gets to your aquifer, which is way before the atmosphere, that's a bad thing, and we need to protect that aquifer. And then there's sort of, by the envelope principle, right? If you're protecting the aquifer, you're protecting all of the stuff above it. But this idea, and it's an idiosyncrasy of the way the regulations work in the United States, drives much of the implementation of that underground injection control program. So I stole this from ClearPath. This is a great graphic, though, that shows you all of these different classes of wells. You hear Class 6 well, sometimes it rolls off my tongue so fast it sounds like classic well, but the Class 6 well is this guy right here for injection of CO2 specifically. Class 5, kind of experimental, non-hazardous. This is what we did for that Wallula well because this guy didn't exist yet. And then there are all of these others. But in every case, right, what you're doing is protecting these aquifers that are sources of drinking water, potential sources of drinking water. Nobody wants to drink 10,000 milligram per liter water, but that is the standard that EPA sets for protecting these reservoirs. So we have this Class 6 rulemaking. We have these permitting regs. I think that having gone through, having survived the Class 6 rulemaking, which feels like it took about 30 years. I think it was more like 12 to 15 years. We do not want to start again with a Class 7 well. I've heard that bandied about for mineralization storage. I don't think anybody wants that. There's also been some discussion about like reopening the Class 6 rulemaking so that we can change and add mineralization in. Again, I think that becomes a really onerous regulatory task, and the Class 6 rule as it exists is sufficient to protect underground sources of drinking water and also do mineralization storage. It doesn't preclude it, it allows it, but it does require kind of fitting into that mold of protecting groundwater. So how do the specifics of mineralization storage impact that mandate to protect drinking water aquifers? What gaps exist in the suite of characterization tools? Again, if we can't use seismic, what do we use? Do we use seismic to identify basement faults and then do the rest of it with logging and hydraulic testing? How do we develop the reservoir simulation tools that allow us to say with credibility to regulators and to communities and to investors and to other stakeholders, this is what we think is going to happen, and based on our ability to monitor what's happening in the reservoir once we start injecting, here's our path to conformance between those observational data and our predictions. Oh, and I also wanted to mention, that's not advancing there. While we're talking about Class 6, there's also an opportunity here, I think, to have a little more near-term opportunity to talk to EPA about doing a geothermal hosted CO2 storage project like the Carbfix project here that we're going to see this afternoon in the United States. Geothermal projects are permitted as Class 5, and that offers some opportunity. Hydrothermal systems are typically much shallower than these 800-meter supercritical depths. You're already moving water, and so I think there's a cool fit there to be able to learn on some of these potential hybrid systems, develop that familiarity with stakeholders and with regulators in the United States, and really do something that looks very, very similar to what's happening here at geothermal fields in the United States. So I'm not going to go into all of this, just to get back to these points of characterization tools, best practices for reservoir modeling, coming up with really robust reservoir simulation tools that incorporate what we're seeing in the laboratory, incorporate what we're seeing in the field, and allow us to be more predictive and more intentional about optimizing these systems. MRV protocols, if anybody wants to talk about MRV, we have a new start project in the United States. It's part of an effort to build a top-down MRV system that incorporates not just the mineralization approaches that exist today, but is flexible and adaptable so that we can incorporate new technologies that come about in the future. And if appropriate, understanding what those post-injection site care procedures are, what might need to change within or be added to guidance for mineralization storage to make sure that we're getting that conformance and we're honoring the unique aspects of mineralization storage. And then a shout out, you heard about this yesterday, this is our Carbon Safe Hero Phase 2 project. This is where we're finally, after having closed the Wallula well 8 years ago, we're gonna get to go drill another well and do some tool development, test some things out. We're really excited to work with, Carbfix is a partner on that, as well as Fred McLaughlin and our friends at University of Wyoming. And then the rest of this is just sort of backup material if anybody wants to talk about MRV. So thank you.
Thank you very much, Casie.
We will take a couple of questions, and while we do that, if we could ask a lot of questions, if we could ask the panel members, I think there's one or two that hasn't gotten their mic on yet, so just go into the side room here. So questions, because Juerg didn't get to answer a question, you'll get to ask the first one in the front row.
Thank you very much, very generous. Thank you, Casie. You know, just to correct me a little bit, you know, it's not fit for purpose for a dissolved CO2 injection, no? The class 6 one. It is, certainly can work, you know, for a supercritical, but I think, you know, the requirements in there, because it requires a caprock, you know, and we know in dissolved CO2 injection we don't need a caprock. That's what I think, you know, meant with not fit for purpose. Second, you know, I learned that the class 5 wells, permits, class 5, were just basically closed for any CO2 injection projects by EPA. That, you know, I was told by Southern Company that the class 5 do not exist anymore, you know, for any CO2 injection, but it's good to hear that it still exists, you know, if it's with hydrothermal. That would be really good to know if that's confirmed, you know. But EPA does not provide any class 5.
I think that's a conversation that can be had with EPA.
Excellent.
Because of that hydrothermal permitting. And to the fit for purpose point, the idea is to protect underground sources of drinking water. If you don't have a caprock, you're probably in the underground source of drinking water, right? Unless you have very high TDS water at the surface, you're probably in a drinking water aquifer unless you've got, and that's where you're coming into the hydrothermal systems. So even though I hear what you're saying there, I don't think that precludes class 6 being fit for purpose if you look at it within the context of the legislation that established it. So, thank you.
We have Sandra and then Sigge in the middle front row next.
Thank you, Casie, for your talk. I have two thoughts, also a little bit referring to Juerg's talk, because I didn't get to ask a question there. One thing about the wells, I mean, we can certainly use class 6 well, but it's not designed for injection of dissolved CO2, and I think it's really important for us to kind of try to fit ourselves into boxes that are designed for other purposes. And it also goes back to the oil and gas and geothermal. We can learn a lot from these industries, but at the same time, we also have to think about, like, how does it look if we just look at the mineralization process and injection of CO2, that we have the right materials and that we have the right designs. We are injecting CO2 into a well that is probably a class 5 well in Iceland. And above our injection is potable groundwater that we are not affecting, because that's what Carbfix is all about. We are injecting below the potable water, we are injecting denser fluids, and we haven't gotten the buoyancy. So that's a very important thing. I mean, none of us wants to contaminate potable groundwater wherever we are. So I think that's also very important for us. So there are kind of these things that we have to kind of maybe use this opportunity to align on. And also in terms of injection of dissolved CO2, I think it's also very important to us, even though we are highlighting the high amount of water that we are using, that we are using this water as a carrier for the CO2. And then we can produce water out of the same reservoir. So we are circulating some of the fluids. It's not like we are disposing of all of this water. So it's, you know, many of these scale-up questions will evolve around reservoir management. So reservoir management will be the key for, you know, the scientists in here that want to do exciting projects, think about reservoir management.
Sigge, because we allowed one more, and then we will continue our discussion on policy and have another Q&A at the end of
Excellent talk, Casie. You know, we have problem proving that we have mineralized. We have to do it indirectly with chemistry. You have problem proving that you have mineralized, but you can look at the skin, and you've done it, and there is mineralization. And then you do the rest with the reservoir modeling, you know. Is there a way, you said you can't do, 3D seismic. Is there a way to image this with a to see if you have a separate phase down there, supercritical CO2?
We're certainly interested in looking at it. I think part of the problem, there's an old geologist campfire story from long, long ago where you'd sit around the campfire and the old geologists would tell these stories. And one of them is that in the 1980s, 2 oil and gas companies came out and they shot seismic on the same, almost the same line. And one company was able to process it and get useful data, and the other company said, you can't do seismic in basalts. So there are ways to do it. It comes down to processing. I think back in the very, very, very old days when that was all done largely by hand, I think it was sort of not worth the trouble. Now, as we have the opportunity to get more data and use some of the novel metamaterials, like some folks on Todd's team are looking at creating metamaterials that become subsurface contrast agents that allow you to be very specific about what you're resolving in the reservoir. That might help us get around some of those, some of the challenges with imaging basalts, but some of it is just the limits of propagating sound in, across very bright reflectors. And I don't know how much we're really going to be able to collapse that down. But I do think going in, being able to monitor your groundwater or monitor your reservoir fluids, monitor through selective sampling, if you're going to go in and take core plugs, I think that's a really important part of validating and parameterizing your reservoir simulators. But ultimately, it's going to come down to the old standards of pressure monitoring and fluid chemistry.
Well, I guess as soon as you scale up, let's say if you have 100,000 tons there,
Yep.
then you might be able to image it.
Yeah. Possibly. It's possible. And I think that's one of the things that we're interested in, taking our reservoir simulators and also parameterizing some of the if we can create synthetic geophysical data sets and just see what those would look like under different scenarios, that's part of the very nerdy, sciencey stuff. Again, like if there are postdocs in the room, reach out. There's so much cool science to get done. Or professors who have postdocs who want to come do this stuff. There's a lot of questions to be answered. But the near term, how do we get these things permitted for Class 6 so that people like Carbfix can come in and actually deploy projects? I think that's a much nearer term, constrained set of questions that we have to answer.
Thank you.
Thank you very much, Casie. Thank you. We will continue our discussion on policy, look at it both in the US and Europe. And I want to invite the moderator, Anu Khan from Carbon 180, and the panelists to the stage. Welcome.
Let's mix up the genders a bit, maybe.
Hi, everyone. Should we get started?
Yes.
Well, awesome. Hi, everyone. My name is Anu. I lead the Science and Innovation Program at Carbon 180. For those of you who might not be familiar, Carbon 180 is a U.S. federal policy NGO that designs and champions equitable and science-based policies to bring carbon removal to gigaton scale. So we think a lot about where all of that carbon is going to go, and when we store it at gigaton scale. So I'm super excited for this panel on the policy context for mineral storage in the EU and the US. My hope for this conversation is that we'll revisit, synthesize, and hopefully dig a little deeper into many of the topics that we've heard about today, including Casie's presentation. We had a bunch of questions about Class 6 that I was rewriting as Casie was answering them, and so we'll do our best. But of course, I'm super excited to have this conversation with this incredible panel. So maybe we'll start off with some introductions. Anna, do you want to?
Yes, hello everyone. I'm Anna Dubowik, and currently I'm a consultant based in Brussels. Previously, I worked with Negative Emissions Platform, which is the trade association promoting technological carbon removal. And I also worked with Global CCS Institute in the past, and with the gas industry on CCS and decarbonization with blue hydrogen. I'm excited to be here. Thank you for the invitation.
Hi, everyone. Also very excited to be here. I'm Sasha Stashwick. I work with Anu at Carbon 180, and I'm the Director of Policy there. So I look after all of the policy advocacy that relates to the technological carbon removal solutions.
Hey everyone, I'm Jack Andreasen from Breakthrough Energy. I lead the carbon middle management portfolio over there. And Breakthrough is a lot of things. We have an incubator accelerator, we have a venture capital firm, we have project level financing, a media company. I work on none of those. I work for the policy team. So we engage with environmental NGOs, congressional members, and the general public to advance carbon management solutions.
Good morning, everyone. My name is Tamme, and I'm a Managing Director of Climate Principles, which is an advisory that is working on carbon removal, carbon capture, and carbon markets. I myself have worked in climate policy for close to 20 years now, and these days I also wear some other hats. For example, I'm the chair of a zero emissions platform, which is in Europe the leading platform that is looking to advance the deployment of CCS. And I'm also quite active in different organizations working on carbon removal. And very pleased to be here. Thank you for the invitation.
Awesome. Well, yesterday we heard a lot about the broader policy context in the EU and the US. So I want to dig into that a little bit more. Starting with the US, in Sarah's presentation, we heard about, of course, the bipartisan infrastructure law, the Inflation Reduction Act, both of which have significantly increased funding for CCUS and DAC in the US. Jack, maybe you could speak a little bit to, how significant are these investments compared to what has come before? Is it natural extension? Are we in a whole new ballgame?
Yeah, it was really a stepwise change in the funding available for carbon management in the United States. So taking it apart into the two pieces of legislation, in the Inflation, in the Infrastructure Act, you have a myriad of different programs, all amounting to about $12 billion in total funding for carbon management. And this is spread across the value chain. There was $2 billion, a little over $2 billion for CO2 storage. There was over $2 billion for transportation infrastructure. There was $3.5 billion for the DAC Hubs program. And those are the sort of high ticket items in the total dollar amount, but there's a number of other programs for relatively smaller dollar amounts that are also consequential, including a $310 million CO2 utilization program that is a de facto procurement program. It allows for universities, municipalities, state and local governments to be able to buy products like concrete that use injected CO2 into it, effectively bringing down the cost of those relatively more expensive technologies at the moment. And then on the Inflation Reduction Act side, you have 45Q, which received enhancements not just in the point source capture, but also in direct air capture for both storage and utilization. So those 45Q credits are currently not capped. So any project that can prove that they capture CO2 and inject it underground and comply with both the EPA and Treasury standards to receive the 45Q tax credits will receive as many as they can do. So yeah, it was a massive increase in funding to carbon management. And so far, the DOE has done an incredible job of getting many billions of those dollars already out the door in a really judicious and thoughtful way.
Sasha, I know we've talked about 45Q, not just the credit enhancement, but increased accessibility to that funding. Could you speak to that a little bit?
Yeah, maybe building on what Jack just laid out, I think it's a really just important nuance to layer on top of just the credit value. So Jack's absolutely correct. These tax incentives are uncapped, so nobody could claim the credit, or everybody could claim the credit who meets the standard. And so with a program like the DAC Hubs program, we know that there was $3.5 billion. It's sort of a fixed pot of money. The federal government is granting out that money, offering up a 50% cost share for these big projects, billion-dollar projects, and obviously that's meant to unlock additional private capital, but we sort of know we can value the federal expenditure piece of that program. With a program like 45Q, as we're saying, it's sort of as many people as meet the criteria can claim the credit. And so ultimately, it's a little bit unknown how much we ultimately end up investing or incentivizing these projects with the tax incentive. And I think the other point to make there is that the tax credit has been around for a while, like 15 years, but it was at a much lower value that was ultimately not compelling for project developers for a long time, right? They weren't claiming it because it wasn't rich enough to make these projects financially viable. So what happened in the Inflation Reduction Act is that we had enhancements to the credit. We just celebrated the 1-year anniversary of the law, and those were not arbitrary, right? So there was a lot of analysis, for example, that showed that at $85 a ton, certain categories of CCS projects, like CCS on cement plants, come into the money. They become viable at that level. So I think it's just important to understand that the credit itself is enhanced. It's a richer per ton value, but also you might see more developers taking up the credit. So there's sort of like that multiplier effect in terms of the ultimate value of the policy.
Yeah, that makes sense.
Can I make one more point?
Yes.
One more very wonky point is that I think we also saw an increased delta between the value of the credit for enhanced oil recovery and for storage. So it's not just that the absolute value of the credit increased, but the relative value of capturing carbon, either point source or direct air capture, and going the storage route was also part of the policy.
Yeah, which ties back to what we heard yesterday, that most of the storage today is through EOR in the US, but now we've sort of flipped potentially the economics of that relationship. Another piece I think that's really important in the US IRA context is kind of how is this being perceived beyond the policy community that created the law? How is industry perceiving this? How are communities engaging with these new laws?
Should I start on that?
Yeah.
So I think we have to be honest that a lot of portions of our own movement in the environmental community and important partners in terms of the environmental justice movement are anywhere from pretty opposed to carbon dioxide removal, in particular the technological solutions, to maybe at the sort of generous end skeptical, let's put it that way. And I think one good thing that we saw was that, for example, with the DAC Hubs program, when DOE made its initial awards announcements last month, I guess it was, the projects are not going to be using any of the CO2 for enhanced oil recovery. So this is like a major bright line, I think, for a lot of portions of the environmental community and the environmental justice community. And I think from our perspective at Carbon 180, to the extent that we can really decouple a technology like direct air capture from being used for generating more fossil fuels, I think that's a good thing, right? We want to be talking about a technology that's for the purpose of removing carbon from the atmosphere and reversing climate change. So I think we really supported that decision. We had advocated for it. We supported it. There's sort of this separate question, though, beyond just enhanced oil recovery, which gets a lot of attention, maybe too much. I think there's a separate issue, which I actually think is the more meaningful and more salient issue that we're going to be dealing with for years to come, which is what is the role of the oil and gas sector in the direct air capture industry. And you see parts of our community that are really, I think, concerned or quite oppositional to the idea that it's going to be oil and gas companies or their subsidiaries that are the primary beneficiaries of these policies. So just to say, I think we just have to be conscious of those dynamics. From our perspective at Carbon 180, I think in the absence of a framework to really define what does it mean to have a good DAC hub, we're kind of using as a proxy for that, like who is doing the building of the DAC hub. And I think it's incumbent upon us in the NGO community to actually come together and align around a detailed set of criteria for what do we mean when we say we want high accountability, just and equitable DAC hub. So the more we can do that, I think the better. But just want to say that this is going to be I see this as a major part of our work over the next few years.
Absolutely. So shifting gears a little bit from the US context to the EU context, we heard from Daniel yesterday about a lot of the industrial policy that DG Klima is doing, very different flavor from the tax policy of the US with the Net Zero Industry Act and the EU Industrial Carbon Management Strategy. And maybe you could start us off with, Net Zero Industry Act. Is this a major shift in how the EU thinks about CCS policy? Is it a natural extension of what's come before? How does it fit into that context?
Yes, that's a good question. I see it more as a continuation, and yes, well, we don't have that many developments to boast about. As Daniel said yesterday, the EU is not a tax authority, or as to put it, the EU doesn't have a competence in fiscal matters, which doesn't exclude some tax credits on the national level if there was a will. Net Zero Industry Act comes as I would say, a target before a strategy. So first we proposed this 50 million ton storage injection target, and now we are looking into developing industrial carbon management strategy. The conversation in Brussels is about, it did come a little bit as a surprise in terms of a mechanism, as a way of application of carbon take-back obligation, which was just a theoretical academic option that was listed by CCUS forum stakeholders, but no one really expected that. It came out of the blue, for some people at least. The conversation in Brussels is now about how the target is calibrated. Of course, the regulation, the proposal is applicable to EEA, so once it's adopted, then negotiation will also start with Iceland, Norway, but the Commission is very clear that this will only increase the target, that it doesn't mean that we will be able to use all the, Norwegian oil and gas capacity to fulfill that. And there is a little bit of a discussion about, the number itself. Commission says that all the announced projects are amounting already to 80 million tons. So 50 million tons seems a fair number. The industry is saying more that we would only have in operational announced early stage, we could see 35 million tons. So we would really need already Iceland with Coda terminal, we would need Norway with Northern Lights, we would need ideally the UK. Of course, this is not possible now. So we have a lot of discussion about the target. We also have a lot of discussion about, the whole target sits in Net Zero Industry Act. It's all about manufacturing of net zero technologies. So value chain for geothermal, for solar, for wind, for fuel cells, even for nuclear. So support for this sort of industrial, we call it valleys, not hubs. And then this target sits as the only element that is actually helping the hard-to-abate sector, that is actually the only, I would say, climate-related, not clean tech-related strictly. But it sits with this idea that, then we need to keep some industries like cement, steel in Europe, and we need to provide them with an option to store their CO2. The conversation is about incentivizing whole value chain, so not only storage, but we would ideally see incentives and framework for cross-border transport, for infrastructure or build out of the CO2 infrastructure, either repurposing old pipelines or building out new CO2 backbone. So there is a lot of thinking going on in Brussels now how to sort of maybe to mirror the hydrogen strategy with the hydrogen backbone, or how to proceed with this extra layer of complication of adding extra gas to the gas grid. The most vocal points from the industry are about recalibrating the target and including EEA into this, or proceeding slowly and actually putting more pressure on member states to, the issue seems to be, Eva should know very well, making sure that member states issue enough of licensing rounds annually so that there is, well, enough opportunities for the industry to apply for that, and also to look at saline aquifers, not only depleted oil and gas reservoirs. And also to put, to actually, what we have in NZIA is a strategic net zero project, so also to include this transport and capture part of it, part of equation in as a net zero strategic project, which would then give them, well, priority and a little bit of faster permitting on national level. So to see it as a whole value, not just storage.
Yeah.
Because the storage, well, operators feel a little bit cornered, but also, like, I see here an opportunity for mineral storage to come in as a, of course, oil and gas developers don't have to provide the storage just with conventional stores. They can use third-party operators or any other providers as a way of cooperating. So I see it more as an opportunity for mineral providers.
Yeah, I really appreciate what you said about Net Zero Industry Act as target than strategy, because the US were like funding and then the whatever comes out of that. So Eva, when I think about EU climate policy, especially in contrast to the US, I think about the ETS. So maybe you could speak a little bit to how these pieces fit into this broader scheme of the emissions trading mechanism.
Yes, indeed. Let's also bring in carbon markets into the discussions. So as you all know, in the EU we have the emissions trading system, the world's largest and I'd say most successful carbon markets, especially if you look at the carbon price. So today we're discussing the subsurface mineralization, and this is a technology that can help either with reducing emissions or with carbon removal. And for these two elements, we actually have different policy frameworks, either present or in the works in the EU. And of course, everything looks in the EU very different from the US. So anything that has to do with reducing emissions that is under the EU ETS, this is where carbon capture and storage, including the subsurface mineralization, is covered under the ETS. So if the CO2 is captured from the plant that is covered under the system, the whole project can benefit from the carbon price under the ETS. However, if the CO2 is captured from the source that is outside the ETS, you cannot really make use of the carbon price. And furthermore, if you're capturing atmospheric CO2, we don't really have these novel carbon removal methods part of the EU policy framework yet. Because they're not even under the EU 2030 climate target, hopefully, and I think most likely they will be under the upcoming 2040 climate target proposal, looking at Daniel up there. And so on the side of reducing emissions, we have the ETS, and on the side of carbon removal, we have the proposal for carbon removal certification framework, which came out at the end of last year and is currently going through the legislative process, so it's not yet agreed. And under that, the technology by Carbfix is also included. For now, right, it's not agreed, but that's where the discussions are going. And I think it's useful for the people in this room to know that in order to develop methodologies in that certification framework, we have an expert group established under the European Commission that is going to have a 2-day workshop in October, specifically looking at industrial carbon removal methodologies, and subsurface mineralization also comes up there. And the actual methodologies will be only developed once the framework has been established. And that's, I would say, maybe we can start working on those from spring next year. Yeah, I'm using we because I'm also a member of that expert group. But I forgot to say what the certification framework was about. It's really about quantifying these novel carbon removals that are currently not within the EU climate policy scope, so that over time we have the understanding of the carbon accounting and all that comes with it, and we are able to include them within the scope. So another, I think, important or let's say interesting aspect to bring up as we talk about the ETS and we talk about the CRCF There are also increasing discussions about including removals in the EU emissions trading system going forward. If that would be the case, then whether this subsurface mineralization is used to capture, to reduce emissions or remove emissions, both could be kind of covered under the ETS if we would end up there. Of course, there are very many different ways of including removals there, and there are exciting discussions among stakeholders. But I think most importantly, we have to wait for 2026 to see what the European Commission puts forward as their thinking, how it could happen in practice. And the years up until that, I guess we can just continue shaping this idea among stakeholders and also feeding that information to the policymakers to do some capacity building.
Mm-hmm. Yeah, so a lot happening on the policy front in both the EU and the US. In my role, I spend a lot of time with startups and companies in the carbon removal and carbon management space. And I think one thing that comes up a lot is how durable or reliable are these policies that you're building your business model around? So maybe we could speak a little bit to that both in the EU and the US context. Could these policies change in the US if there's a change in administration? Is there a chance something fundamentally changes?
Yeah, I can start. Yeah, I mean, in terms of political change in the United States, I mean, truly anything is possible, but outside of that, you look across the political spectrum in the US, and there isn't much agreement on anything in climate, but there is, generally speaking, on carbon management. And so for the storage programs, the DAC hubs piece of legislation was bipartisan. The recently introduced earlier this year CREST Act, which is an RD&D procurement bill, was a bipartisan bill, and that's for carbon dioxide removal. So you have a pretty strong support across the political spectrum in the US. So I don't have as many concerns about sort of what are spoken often as like clawbacks if the administration or political winds would change. But yeah, you can never count on US politics, so we'll see.
For the EU, well, I have never seen a directive being repealed yet or a regulation. What we are facing in Brussels is the European election in May 2024, so a little bit of a slowdown. And at some point there was even a little bit of like insecurity about whether or not the old Commission will really deliver on the industrial carbon management strategy, and we as a group of stakeholders came together and pushed for at least having a communication by the end of the year, so that then the new Commission can start working on it somewhere after May, June, second half of the year. Of course, communication is just a communication, so it will probably include proposals for other legislative tools. So we see a little bit of a break, but we already have a very good head start with NZIA target, and already the industry is fully aware that they will have to start, prospecting. Yes, it's in Europe. It's rather adding layers and layers of clarification into different pieces. So we see it very much with CCS directive now, with extra explanation, revised guidelines that already have been revised 5-6 years ago. So we have annexes and additions and quite a good continuity.
Absolutely. Anyone else on reliability policies? Okay. So in this broader policy context, we've talked about the EU approach, the target strategy, regulation of industrial emissions. We've talked about the US approach, which in IRA and bipartisan infrastructure law had a lot of tax subsidies and also cost share for demonstration projects. One policy lever that we haven't discussed yet is procurement. Sasha, can you speak a little bit to how that lever would fit into climate policy for carbon management?
Yeah, my favorite topic. Before I worked on carbon removal, I worked on decarbonizing heavy industry, and we used to talk a lot about supply side push and demand side pull. So we've talked about, as Anu said, the incentives that were in these big pieces of legislation that went through in the US in 2021 and 2022, and they're sort of these robust supply side deployment incentives, which is sort of the supply side push, let's call it. And then procurement comes in as the demand side pull. So what we saw in tandem with the announcement of DAC Hub's awards was DOE coming out with the carbon negative shot, which had a lot to like in it, frankly. There was a lot of support for R&D and pilot projects across really a diverse portfolio of carbon removal solutions. Anu, I think on Twitter you called it end-to-end innovation support for any plausible long-duration pathway, right? So a lot to like there. And at the same time, DOE announced first of its kind $35 million carbon removal procurement prize. It's the first time the federal government is stepping in and doing this, effectively buying carbon removal as a public good. And ultimately, you know, that is a big part of the vision that we believe that we need to have for the carbon removal market long term at the scales that we're talking about. And so I think it's important to make maybe 3 points about that. So the first is that it's just like really smart policy in my view to be, you know, investing in bringing certain solutions, technologies, de-risking technologies, bringing them to market with high standards, and then at the same time making a market for the outputs of those projects. In this case, the output is carbon removal. So it's just like really smart synergistic policy, a holistic approach to building out this sector. I think the second thing is that the way we view this impact, I think, should go far beyond just like $35 million of expenditures. That's sort of the direct amount of money being spent. But the idea of the US federal government stepping into this role of setting high standards for carbon removal and really sort of establishing that product profile and the demand signal it sends, in and of itself, that signal is an incentive that I think goes far in excess of just the specific dollar amount that's in this prize that DOE announced this year. And then finally, I think, again, like we just see this as a huge opportunity. If the US federal government establishes these high standards, gets the momentum going on procurement, right? Those standards have the possibility of raising, I think, you know, a lot of boats, having a real, having spillover impacts in the private markets, potentially even sort of international cooperation and agreements around carbon removal. They can be used in the future as the basis for congressional legislation to have, you know, bigger procurement programs on the basis of these standards. So that standard setting role and the opportunity before us with this procurement prize, I just want to kind of underscore that it kind of looks small in context, but has potentially really outsized impacts if done well.
Mm-hmm. And I know we're a little bit over time. I want to bring it back to mineral storage because we've talked about this very broad policy context, but in order to have subsidies, to have procurement, we need to have a way of permitting mineral storage in a given regime. So maybe we could just briefly touch on how is mineral storage or subsurface mineral storage permitted in the EU and the US today? Maybe you could start us in the EU.
Well, so mineral storage is included in the directive, and recently it's been very nicely, clarified. I mean, several questions have been clarified with the revision of the guidance document. That are non-binding, but they are treated more or less as a good indication on how what are the requirements for permitting site characterization, transfer of responsibility, and financial security. So we got good definition, good clarification. I mean, this is not final yet. As Daniel said yesterday, this will be final by the end of the year now, not end of September. So I think the consultant is still revising all input that's been submitted. So we got clarity around definition. So cap rock, that it only sort of applies to conventional storage. What is leakage itself? So it's basically about three-phase CO2, and we can only possibly look at, well, leakage with CO2 dissolved in water. If it migrates upwards in updip in saline aquifers, then it can dissolve, and this sort of very, I would say, rare risk of leak could be assessed at some stage for mineral storage. But otherwise, like it's the definitions have been clarified that, well, CAPRO definition, CO2 plume monitoring doesn't apply to mineral storage. Also, what is important for storage operators is that there is a monitoring period under the transfer of responsibility of 20 years. But of course, with mineral storage, mineralization happening so much faster, we can assume that if a competent authority is okay with that, and this could be less than 20 years. This period before post-closure, before the transfer of obligation to the competent authority. So then it reduces, I would say, cost and pressure on the operator itself. And then there was also a lot of discussion around financial security. So different well, insurance tools, for example, or corporate guarantees, or funds, deposits, lump sum that the operator needs to put aside to provide, well, guarantee in case of leakage. So in that sense, there were a lot of comments from different stakeholders, not only mineral storage, to make this amounts based on a risk profile of a site rather than on the volumes of CO2 injected. It should be based on actual risk over time, which then means that for mineral storage, it could be demonstrated earlier that from now on everything is trapped, everything is absorbed, everything is mineralized. So this would shorten and lower the amounts involved in providing financial security and financial mechanism. This is how I see it. Of course, it's still open and up to the consultant and the commission to work out the final version of it.
Absolutely. And Jack, I know Casie set us up, but real quick, how are we permitting in the U.S.?
Yeah, thank you, Casie, for saving everybody at least 5 minutes of your life of hearing me drown on about Safe Drinking Water Act and why we are where we are right now. So I won't belabor you with the history of sedimentary basin storage in the United States and how we got to the current permitting and regulatory regime. Not to say I don't love sedimentary basins. The Mount Simon is my favorite, but as you look, I think the easiest way to think about injecting in the subsurface in the United States is to take an individual project and see how they would move from capture or removal into injection into whatever aquifer it is. So let's take a DAC project. If you were doing DAC on state or private lands, you would be permitting through the EPA. If you were offshore, you would be, if and when the Bureau of Ocean Energy Management issued their regulations on how to inject into the offshore, you would then be going through BOEM, which is a separate federal agency. They haven't issued those regulations yet. They should be coming, imminently. They've been imminent for 2 years, but around the corner. And then if you want to inject on federal lands and federal pore space, that's through the Department of Interior through the Bureau of Land Management, which is under the Department of Interior. So that's where you start. Where are you at? We'll take the EPA in Class 6, so you're on state or private lands. Then as you've set your project in, there's no necessarily geologic categorical exclusion for mineral storage in the United States. There is an often cited guidance by the IRS, which is how you claim 45Q tax credits, that says you could inject, to claim 45Q, you could inject into a saline aquifer, a depleted oil and gas reservoir, an unused coal seam. But it's not, those aren't definitive statements. It's just giving certain types of geologies that you could inject into. So and then there are certain things that Casie and others have mentioned about the Class 6 regulations, again, being made for sedimentary basins, and so not being necessarily perfectly ideal for storage in igneous formations. But as you have permitted and you get your Class 6 well in the United States and you inject into the subsurface, then you go into claiming your 45Q credits, and that is done by contacting the IRS, proving that you have actually sequestered the CO2 through either subpart RR or subpart VV. These are very interesting. I know everyone's thrilled. So if you want to go deep on subpart RR, you let me know. It's fascinating and also great to fall asleep to. So yeah, you permit on whatever land you're on. You claim the credits through the IRS, and then the legal regime in the subsurface is relatively a state-level policy at the moment. So what happens to the CO2 after injection? How long do you have to monitor it for? What happens after the monitoring period for a Class 6 well? It's 10 years post-closure. You have to monitor it, which is another thing that mineralization maybe it is a right fit necessarily for that. Obviously, if you've mineralized, your MRV is going to be slightly different. So this is all to say that at the current moment, you can legally and regulatorily permit Class 6 wells in mineral storage in the United States of America. There are a lot of caveats to that. I currently don't see a way in which it's at scale going to work in the current legal and regulatory regimes. And we should ensure that geologies receive a parity at legal and regulatory levels such that we're not artificially limiting ourselves on the storage potential. I see no reason why the beautiful basalts of the Pacific Northwest should be treated any different than the humble sandstones of Illinois. And so that's, yeah, I'll stop there.
I feel like that's a fantastic point for us to close on. Do we have time for Q&A, or should we?
I think we'll take 2 questions from
Fantastic.
the audience.
There's a third.
Hi, that was great. Thanks so much. Todd Malin with Talon Metals in Minnesota. Could you give some specific examples where you've seen really good community engagement or community support in proposals that have been proposed? Didn't talk much about Canada. We see a lot of really innovative things in Canada, particularly with sovereign governments actually participating as equity owners in projects. For me, that seems like the future, but I wonder whether you have either in the EU or in the US examples that are very specific and referenceable as models.
Start?
Yeah.
So maybe I'll say a few things. Alongside the 2 big DAG Hub projects that DOE awarded, I heard someone refer to them as the charismatic megafauna of the DAG Hubs program, the 2 big projects that we're focused on. There were 19 other awards that were announced for smaller scale, for I should say earlier stage projects. And one is a hub in California Central Valley that Carbon 180 is actually party to. And the idea there is to do exactly what you described, which is to put forward a model for really bottom-up community supported, community-generated, and potentially, ultimately, some sort of like public ownership, community ownership model for a DAC hub. This is a very early stage project. It's sort of a pre-concept project, right? But folks are thinking ahead to putting forward exactly these types of models. I think a very sort of broad statement from Carbon 180's perspective is that community self-determination is a really important aspect here. The people who are going to live with these projects in their backyards should have a say in project development, and DOE has certainly indicated that is a really important value, and in fact is requiring a lot of community engagement as part of the DAC Hubs program. So I actually think there's some accountability even on the DOE side to make sure that as we progress in implementing DAC Hubs, they make good on that promise.
And I would add, keep an eye on the DOE Office of Tech Transfer MRV lab call projects. they're developing MRV frameworks that include both the technical aspects and the community aspects. So I think they're actively working on addressing exactly this. I don't know if I'm allowed to talk, but I did it anyway.
You're allowed to talk.
Thank you very much. We are very strapped for time, so we will keep the next questions for the very short coffee break because we have so much time to talk in the bus and during lunch. So we will reconvene at 11:10. Thank you very much.
The scientists, they approached us at the Reykjavik Energy, and I thought it was a crazy idea. Everybody thought it was a crazy idea. Well, Carbfix is actually a very simple idea. It's actually a natural process already happening. We are taking CO2, mixing it with water, and injecting it deep down into the bedrock, where it mineralizes and forms calcite, which is stored in the bedrock forever.
Yeah, so we have been planning this for quite many years, and you can design a system quite, let's say, easily, and you can test it with relative ease in the laboratory. That's where you have everything is under controlled conditions. You have clean water, you have clean gas, you have clean everything, and you're not dealing with weather. We needed to test the equipment under real condition to see if this would work.
There was only one way to try it out: start injecting.
It was definitely not a success story from day one.
When you are transferring cold water in freezing conditions, pipes tend to freeze and clog.
We are used to malfunctions of equipment.
When you're installing your injection system in a well down to a few hundred meters depth in strong winds, in maneuvering pipes, it can be challenging.
If you are struck down, you need to stand up again.
It gradually dawned upon us that it was actually working.
Then when we had finally overcome all of the problems, it was quite a big step for us.
And once, the science paper was out there, almost ever since then we have just been on this roller coaster. The paper was published in June in 2016. I woke up on the morning after it had been published, and it was just all over the media.
Yeah. This is actually a method that has been developed.
It is mixed with water, kind of a fizzy water.
Will contribute to the fight against climate change.
This could be an answer for many industries around the world that have excess CO2.
Oh yeah.
Let's get that out there, man.
All right. Thank you, Kári. Welcome back. So we are changing gears a little bit. We have our moderator, our very own, Kristinn Ingi Lárusson, and the panel who's going to talk about who is going to pay and why. Welcome.
Hello, everyone. Fantastic to be here. Just to say it, I'm extremely proud to be a Carbfix employee, so it's been a super journey, and we're just starting. So today, the topic, financing commercial mineral storage projects, who's going to pay? But it actually is much broader than that. It actually spans the entire spectrum of what has been talked about during the last couple of days. So, it influences many aspects like the monitoring. Certificates are going to be different, and how are you going to, do the verifying? Excuse me. So it's going to be more kind of in a broader perspective than just focusing on specific project financing. But so let's start by this fantastic panel introducing themselves. So.
I'll go first. So thanks so much for having me. My name's Stacy Kauk. I'm the head of sustainability at Shopify. You may not have heard of Shopify before, but if you've bought anything online direct from the brand, you've probably used a Shopify store to make that purchase. So we provide trusted tools to start, grow, market, and manage a retail business of any size. We have millions of merchants in over 175 countries. And you're probably wondering why I'm here to talk to you about buying carbon removal and funding mineralization. We are one of the largest buyers of permanent carbon removal in the world. We started back in 2020. Many of our companies that we buy from are in the room today, which is really exciting. To date, we've spent over $40 million on permanent carbon removal, and that amounts to about just over 56,000 tons of captured atmospheric carbon with permanent storage.
Well, hello, everyone. My name is Darren Damiani. I'm the Carbon Storage Program Manager for DOE's Office of Fossil Energy and Carbon Management. And our program is appropriated funding from Congress in the levels of $80 to $100 million a year. So my role is to develop research program directions and then use those funds to do funding opportunity announcements and lab calls to do those priority research areas that we plan for. So I'll stop there.
Great. My name is Matt Curley. I'm a manager with RMI. We were founded as the Rocky Mountain Institute based in Boulder, Colorado. We are an approximately 40-year-old, 700-person NGO focused on clean energy and climate change. We do research, analysis, and facilitation to help market-based implementations for addressing climate change. I am on the carbon dioxide removal team, where we are focused on helping direct research and development funding to early-stage CDR companies, as well as early industrial deployments. And specifically, I'm the manager on our direct air capture hub application that was recently awarded by the DOE. And that is located in the Pacific Northwest and is in partnership with PNNL and Carbfix. So happy to be here.
Good morning, everybody. My name is Martijn Smit. I'm the commercial director for Northern Lights. So I'm responsible for the commercialization of Northern Lights CCS project. Where we connect, I think, with Carbfix very well is that we, in Northern Lights, we are putting the words that we talk about into action. So we are building it, we are doing it, and we're gaining experience, and that's what I would like to share here with you today.
Welcome all. So just to put it in perspective, we are talking about two markets funding projects going forward. So we have the sticks and we have the carrots. So we have the ETS and we have the IRA and 45Q in the US. So it's very symbolic that we're in between here in Iceland today and talking about these things. So what the end thing is when you're funding project like that, it needs to be bankable. And that's what I was referring to earlier about the certifications and so on and so on. But just to start on mineralization, this is not a new thing. This has been done for quite some years. First by Carbfix in 2012, and then PNNL in 2013. My question to the, let's say, the American side of the panel, why has this not been utilized more on a commercial scale in your view? And how do you see the coming years to progress in regards to further enhance the scale-up of the technology and funding of mineral storage projects? And if I can start with DOE
Sure.
perspective.
Yeah, that's a great question. I mean, our program actually started in 1997. So we've been doing research on geologic storage of carbon dioxide for well over 20 years. And I would say that over that period of time, we've probably invested about $1 billion over those 20 years. And this is just the annual appropriations. This is not including the bipartisan infrastructure law funding that you had heard of earlier. One of the major key flagship projects with that, most of that money went with something called the Regional Carbon Sequestration Partnerships. There were 7 of them, and one of them was called Big Sky. And that Big Sky partnership is the one that funded the Wallula project that PNNL lead. So that was really our first foray into the mineralization piece. So this is going back quite some time. But remember, there was actually very little incentive at that time. 45Q tax credits were much lower. There was not a lot of industry. We had a financial, collapse in 2009. So we kept the research going, but we had to prioritize. So we spent a lot of our effort and time really in validating technologies, trying to show that the geologic storage was safe and that we had the technology to do it. And in doing so, the mineralization piece kind of fell back on the back burner, so to speak. Fortunately, though, even though that was no longer a priority, I have a pretty good relationship with PNNL, and so we kept funding them little bits of money, what Casie Davidson would call couch cushion funding. But we continued that funding. They had data. They still had research to do. So Todd Schaaf and Casie continued to do that work. So now we're at what Sarah Forbes called yesterday, this inflection point, right? We've been spending a lot of time and effort on what we're calling the validation phase, and now we're moving into what is now an activation phase, meaning that now our focus is on kind of getting the CCS industry going, and we're doing that with the bipartisan infrastructure law. So that has also changed our priorities, and it is now really important that we start focusing on the mineralization piece. So we're so pleased that PNNL and Carbfix are working together now, and that there's so many other things that are happening. It's really giving us a jump start on that delay that we've kind of experienced. So yeah, that's kind of where we are right now. It's not new, but it feels like we're breaking new ground.
Thanks. Maybe Matt, can you comment on that as well in regards to how can we in the coming years, how do you foresee this scale up to happen and materialize, and how can we speed things up?
Sure, I'll try to add on to that great answer. I think the business case is the really important piece. We've heard yesterday that the vast majority of carbon storage that's been done to date was done through EOR, which isn't relevant to mineralization, so we haven't gained experience in that area. And there are project examples like Petronova that work technically, but don't pencil economically, so we don't have the chance to implement storage and gain experience that way. So I think moving forward with all of these new incentives and new momentum around addressing climate change more broadly, we have the opportunity to make these new technologies pencil economically if we get participation from voluntary and compliance markets at a level that makes these projects compelling. And for example, in the Pacific Northwest, that's one thing that we need to figure out, the feasibility both on the technical side, also on the business and economic side, and then, as we heard before, on the community engagement side. So we need all of those things together to move forward mineralization.
Thank you. Stacey, from Shopify perspective, you guys are already, or let's say indirectly, in investing in mineralization. Why hasn't this been taken up sooner, in a sense, from your view, and how do you foresee moving forward?
Yeah, so how it fits into what we're working on is we want carbon removal as part of our corporate social responsibility strategy. We want to be able to pay for those historical emissions to actually be captured and put somewhere. And we'd prefer that they get put somewhere that's durable, and like Professor Lochner spoke about yesterday, nothing's more permanent than mineralization, right? And so that is where we want to put them, because it de-risks those carbon credits. That reversal is way less likely than, say, if we put it in surface soil or in a tree, right? So that's the motivation behind why we're involved, because we want these carbon capture technologies to have great places to put the CO2 that they capture. And so we're getting in early now because we want to make sure that that use case is represented in the project economics. Yes, indeed, there is a carbon credit buyer out there who wants to pay for this kind of a solution. And so the previous panel talked about the demand signal, and this demand signal, we're putting criteria around it. This is what we want to buy. These are the product features of the thing we're going out to the market to get. And so that's why we want to support mineralization, is so that that's there for us down the road when it's available at scale, and today it's not.
Oh, okay. Thanks. So jumping across the Atlantic over to Norway, Martin, from the Northern Lights project, a fantastic project.
what can future carbon mineral storage projects take away from the Northern Lights project in regards to commercialization, funding, and deployment?
Maybe to clarify a little bit for the audience, Northern Lights is the flagship project in Norway. We are 80% ready with the construction of the first phase. And the project was realized largely by the Norwegian government, and they've funded it through a value chain approach. But the Norwegian government, with the history in oil and gas, has taken a very active role in the whole process, because they basically had a subsidy package for emitters, being cement and waste incineration, and transport and storage separately. So we discussed milestones and obligations with the Norwegian government directly for our transport and storage. By the way, it's not a mineralization, but it is a saline aquifer, just to be clear. We received the funding, and the government de-risked the project largely into an investable business case. So the owners, the three owners, are Shell, TotalEnergies, and Equinor, invested, conditional to the Norwegian government investing, and that was now 2.5 years ago. So that is running. We are building it, and the cement and the waste incineration are developing. People have said yesterday the waste incineration of the city of Oslo, there are caps to the budget of the government, so there's maximum funding also to the projects, and the waste incineration has taken a pause in its development to reduce the costs to make the project feasible. But they're still working hard together with the government to make it happen. I think for us, it's really important that it does happen, because every big city in Europe has a waste incineration plant. And the challenge that they have is the access to this, from the city to the shore line. And that's that challenge you have in many cities, actually. So it would be really good if they would be able to succeed. My job was to make sure, and the private investors, there was spare capacity funded to sell that capacity and to be able to make a return on that. So that was the incentive for the private investors. We have succeeded in that. We have 2 commercial customers and agreements, very different in nature. But through our ship solution, we have access to 9 European countries. So we have different industries, different national policies and governments that we can access and provide a solution for. We have an agreement in Denmark with basically waste to power, where there are negative emissions generated, and credit should be given to Microsoft, that have played a very instrumental role in making Ørsted win the tender. The other investor in that case is the Danish government. And then we have the ammoniac production from the Netherlands with Yara, who will be storing CO2 with us in Norway. That fills up the phase 1 largely. So now we need an investment case to scale up. Yeah. And for the scale up, the regional government has funded offshore spare capacity still, but we need to scale up the onshore facilities. And that's being discussed as we speak. Okay. I think the negative emission plays a big role.
Yeah, absolutely, and that's kind of, we started the dialogue in the US and moving to Europe, where we have a totally different, ETS is of course, the stick, but also being subsidized by the Norwegian government. Asking you again, and Stacey as well, from the opposite side, if we look at the mandatory market versus the voluntary market, what is your view on these markets? Because these are totally different elements, and in regards from demand and supply. Are they competing against one another? Are they supporting one another? Is there a hypothetical better situation, or what? Start with you, maybe.
Sure. So, I mean, there was some discussion yesterday about the wild, wild west of the voluntary market. I think that is in fact true, which is the opposite of the regulated market. That is very well defined and well run in terms of the rules of engagement. So yes, separate and distinct for sure. But I think that there's different roles to be played in scaling the climate solutions. I think one of the luxuries that I have at Shopify, being a member of the voluntary market, is we can go out and we can experiment. We can support a wide range of solutions. We're very fortunate that we have a relatively small footprint and a big budget, so we can pay high prices and make sure that we have enough shots on goal that these technologies and solutions get proven out, and then we can, hopefully hand them off and they get incorporated in the rules of engagement in the regulated market. And conversely, I think the voluntary market has a lot that we can glean from the regulated market in terms of methodologies and protocols and those rules of engagement. So I think they work together, and I think they have different purposes.
Yeah, I was thinking, I offer transport and storage services, and I need an investment case and have limited capacity of what I currently can do in the facilities, right? So in a way, they compete for that capacity. But it's also fair to say that we need to scale up big time, and we will develop further capacities as this demand is growing. So for me, there are very different markets in many ways, because the negative emissions are very often greenfield operations, much faster to market, much simpler to execute, compared to the EU ETS regulated markets, where you have big industries, big organizations, brownfield operations, harbor infrastructures that need to be established, which takes a bit longer. So but then you also have the aluminum smelters with low fuel gas concentrations and pressures, waste incineration also a little bit. So there is a clear link also for the direct air capture technologies there. One of our missions is to establish a new business for Norway after the fossil fuel. We need to get away fundamentally to have a sustainable business from subsidies. So we will collaborate and try to develop the technology for direct air capture within Norway and close to our site.
Okay. Moving Matt and Darren in regards to a slide that was actually used yesterday. The International Energy Agency has estimated approximately 1,000 billion tons need to be avoided by 2060 if we're going to achieve the set goals of the Paris Agreement. About 12% of that amount is estimated to be carbon capture and storage. How do you foresee your role in that? That is RMI and DOE in that transition, and especially how do you foresee the role of carbon mineralization storage project in that equation? We'll start with you, Darren.
Sure. So during the day yesterday, you may have seen some maps that were showing where our basalts were in the United States, and that came from our carbon storage atlas. That atlas takes a lot of the data from the regional partnerships I'd mentioned earlier and makes estimates about how much storage resource there is in the United States. We don't say capacity anymore because that's attached to something called the SRMS, the Storage Resource Management System. So we refer to resources when we suspect that there's storage there. But anyway, we have this map, and when you look at that, it looks like, and for saline storage and storage and saline reservoirs, 2 to 20 trillion tons of storage capacity. Well, that's great. That's centuries of storage. The problem is that those estimates are based on a volumetric calculation that assume a storage efficiency, but it also assumes that all of that pore space is utilized, and while it's useful to have that information, we have to think about this. It's practical storage. How much of that are we actually going to use? So while we have these big numbers, chances are it's not quite so big. So the administration now has set some really ambitious decarbonization goals, right? 0 emissions by 2050. And there's a Princeton report that shows that by 2050, that means we'll probably be injecting at levels of over 1 billion tons of CO2 in the US. Over 1 billion tons of CO2 per year. That's a lot of CO2. So it makes sense for us, from our perspective, that we need to understand what all of the storage resource potential is, right? There's been a lot of focus on supercritical CO2 injected into saline reservoirs. And we're doing that, and some regard that as the low-hanging fruit. But now really all of the options become super important. Mineralization becomes really important. We're looking at, there are natural CO2 domes in the United States. Maybe we can reverse and go back. There's depleted oil and gas fields. Can we now put that carbon back there? So the program going forward is looking at all of these things. And so mineralization definitely has moved way up as one of those options. We recently we're funding 7 projects. It's about $1 million each, $7 million to do resource assessment across the U.S., both in situ and ex situ storage and mineralization. Some of you might be there's and even Office of Science is involved. They have the Energy Frontiers Research Center led by the University of Minnesota. And they're looking at the basic science. You heard Todd Schaaf say yesterday, we haven't got it all figured out with the chemistry. So there's even some basic science research that needs to be done. So we're from basic science all the way to applied. But in addition to that, what's really important is the economics. And that's where the finance piece comes in. It's nice to know where all that is. Chances are we're not going to utilize all of that because there's going to be economics involved. So where is that convergence going to be? And so our program is focusing not only on where the resources are, but what are the economics of that, and then start to build out from there. I think Professor Lochner made some very powerful arguments yesterday about carbon mineralization and carbon certification. And I think it's possible that we may migrate in that direction. But where we stand now with the carbon decarbonization goals in the US, we have to explore all our options and start to understand the economics. That's just the storage side. There's a whole transport piece to that. There's a capture piece to that. So there's a lot of challenges.
Yeah, I absolutely agree. Matt, comments on that?
Just to build on that, RMI sees its role as helping to understand the economics. So we do research analysis and help implement first projects. So we can help the public and private sector establish these examples that then the market can follow afterwards. So specifically with respect to the 12 gigatons of storage you were talking about and mineralization, one thing that we are doing is leading the way on helping industry convert to clean technologies. So maybe there's more hydrogen steelmaking that can be done and less CCS is necessary than some predictions that have been made. And likewise across industries.
Yeah.
And then as far as first projects go, again, going back to our facilitation of clean steel, clean ammonia, direct air capture, and pushing forward mineralization options by, again, understanding the technologies and the economics and helping the market take on these solutions.
Thank you. Picking up the point that I think two of you mentioned on Klaus' quotation since yesterday, and I actually wrote it down because I thought it was quite interesting. So the statement is, mineralization offers the best guarantee of performance. Can I ask Stacey and Darren, maybe from your point of view, you just mentioned, Darren, that perhaps the guidance will move into that direction. That is, to have what word we want to use, a premium service or premium product. How do you look at that? I mean, moving forward.
I mean, I don't want to repeat what I just said before, but I think, you start to hear arguments like that, and it does, from a program manager's perspective, I mean, these are things that we like to consider. How does that work? And we start thinking about that. But as I said before, we're covering the entirety of the United States. And so it would be nice to be ideal. It'd be nice to know that, there was that word storage, but that doesn't mean really permanent. We do intend it to be permanent. But the way we see it now is that we've got to start storing CO2 now. Yep. Mineralization still needs work in terms of really understanding the chemistry, the migration, because it's important from a regulatory standpoint from where we are that the Environmental Protection Agency who regulates this, whether it's the federal or the states that have primacy, they need to understand that. They need to understand how that works. And until they've done that and vetted it and then start issuing permits, hopefully we'll get one in Wyoming. You heard about the HERO project. again, I think ideally that would be great. We like to think about that, but we're also have to think about what the opportunities are now. How can we start getting CO2 stored right now? And again, if we migrate towards that kind of ideal situation where the CO2 is actually chemically altered and permanently stored, there's a very attractive thought about that. There was some discussion yesterday about why are we calling it storage or sequestration? I was thinking on that. I don't know if it's a very good suggestion, but I started thinking, what about carbon restoration? Mm-hmm. Because we're putting it back where it came from. It was taken from the ground, and now we're putting it back. So, those things they evolve. It all changes, but I think that, understanding where the resources are, what the opportunities are, will ultimately start to converge to what works.
Thanks. Stacey, from your aspect, I mean, is there such a thing as a premium, mineralization storage? And quoting back, mineralization offers the best guarantee of performance. Would you look at it and would you pay more for that?
I currently pay more for that. As a carbon credit user and buyer, and we retire them against our footprint, we have a full range of solutions. We have forestry solutions, soil carbon solutions, mineralization, attached to all sorts of different capture methods. We've got concrete credits. We're doing the full range at the moment because we want to help all of them get proven and start to scale and commercialize, drive down the price, right? Yeah. And I think that's the point here is we would pay a premium because Dr. Lochner alluded to this, what do you do in 10 years when it's been re-released? Mm. Well, the gold standard would be to rebuy and to over and over and over again. And so if you're doing that for say 100 years or 200 years, that's expensive. Yeah. So when you look at the compounding that happens, I'm not sure you would be paying a premium depending on the project economics for mineralization storage credit. But yes, those are worth buying for us because it really reduces risk of reversal and that reputational and brand risk that goes alongside it.
Thank you. I just want to state that we at Carbfix, we are, we don't claim we have the silver bullet in regards to, the technology. We need all the technologies, and mineralization is one of them. So just want to make that clear. As time is running, very, very fast. One question for the panel, and very quick, simple answer, and hopefully we can then take some questions. Is there a mechanism, or what is the mechanism that we can actually accelerate the growth of CCS projects and the storage aspect of it? Just, Stacey?
Make everybody support those projects. I think it's a policy and regulatory landscape that incentivizes the economics, but also incentivizes the procurement side of these environmental attributes in a responsible way and an equitable way.
Yep.
Definitely money and learning by doing. I think Jan said that yesterday. That is absolutely key. Yep. You have to do projects. You have to learn how they work, how they break, how they fix them. And there's that, and there's been talk about community engagement piece that is absolutely critical, but there's also the legal side. In the US, there's different land ownership. In Canada, no problem, the Crown owns everything. But in the US, there's federal land, there's state land, there's private ownership of land. You look at Wyoming, it looks literally like a checkerboard. So, you've got to deal with that. Yeah. And you still have to do out and do those projects. And in that case, there's learning by doing on the technical side. And in this case, there's a name for that too. It's learning by suing. So,
Matt?
I'll say one of the same things in a slightly different way, and that's buyers. If you buy it, they will build it, and if you build a lot of it, it gets cheaper.
Yeah.
And I think that's how we get more stuff done.
Okay. Martin?
I wanted to use the opportunity, I think collaboration between government and corporates and also public. I know there's a lot of people online here. What Carbfix has put off here, while you're doing it, I'm working every day very hard, bringing people from across the world to share experience, to team up, build relationships, and leave with more knowledge and as an ambassador for CCS and mineralization, I think is very well done.
Thank you.
Northern Lights tried to contribute last night, but really well done.
That's a good contribution by you. Thank you for that. Well, maybe some questions if we have time. Vala, what do you say?
How many hands do we have? I think we'll start with the one online, and then we'll start at the top since we've been.
So one from the online community, from Elsan. She would love to hear more from Stacey on the appetite amongst corporations to continue and scale up purchases of carbon removal credits. Are you doing this because you anticipate more regulation requiring it eventually, or is it consumed sentiment enough?
Okay, so I think there's two parts to that question. Do we see more buyers coming? I think right now we've got some technologies that have to prove themselves and start to scale to bring down the cost to make these kinds of carbon credits viable for most businesses. So things are a bit expensive right now, and there's a lot of uncertainty also around the MRV and the methodologies. These are first of their kind technologies and approaches. So I think that there's a lot of corporate buyers who are waiting for these things to get sorted out before they're going to feel comfortable entering the market. So we've got that. And the why behind Shopify being involved early on, it is about future-proofing our business. We do expect regulation. We will be eventually a regulated sector somewhere in the world one day. Not yet, but we will join that. And we also think that there's going to be an expanding role for CDR above traditional offsets in the corporate climate commitment space. And we're going to be a small buyer. So if we don't get in now, it's kind of selfish, but if we don't get in now and have these relationships and understand the technologies and the options, we're not going to be able to secure the credits in the long run out in the market because we're not going to be a big buyer. And so this is a way for us to get in now and establish these relationships so that we're prepared.
Thank you. There was one up there, yes, the chosen one, and then one in the front. Our last question for this panel.
Thank you. So my name's Arthur Stockreef, work for Canada Nickel Company. I'd be interested to know what your short and long-term price forecasts are for credits and where you expect them to sort of label or steady out, because that's really important for making the business case. And yeah, so what are your views on that?
Who is that question to? Is that intended for the panel itself or anyone specific, just on the... I mean, if you... Go ahead, please.
So I don't have a crystal ball. So there's a very large range, and I don't think there's a good answer to your question, but I think it's a really interesting observation, especially in the contrast between the voluntary and compliance markets that we were talking about before. Because in the ETS with a variable price and the California Low Carbon Fuel Standard, also with a variable price, it's difficult to finance projects without price certainty. And at the moment, that's one advantage that the voluntary market has over the compliance market. But again, it's really hard to know, is carbon removal going to be $50 a ton in 20 years? Is it going to be $250 a ton? Is Climeworks going to be able to bring costs down from their over $1,000 now to their goal of $200 a ton, not inflation-adjusted dollars? So it's really hard to know. And again, it's getting projects built is dependent on having enough of a price and a stable price over time. So that's a big challenge that we need to solve.
Can I just make one comment? Because I talked about collaboration. I mean, this question actually comes back to you. At the end, in my view, at the end of the day, it's about green premium products. This negative emissions is a global price market. It's not US or Europe, right? Yeah. It's global. How much are you willing to pay for cement or your garbage from your front door, right? So it's not a... I mean, the ETS in the long run, we would prefer to have green premium products paid for by the consumers.
Let me first agree with what you said. We need all options on the table. We can't just say mineral sequestration is the holy grail, so we focus there. But let me turn this around and put it maybe as a question to all of you. If you have that performance standard, which is set by mineral sequestration, shouldn't we start holding the others to the same standard? Because you can do it. You can separate the certification that it's done from the actual performance of that and make it whole on the other end. I want to get a certificate which guarantees the permanence. I know that I have to buy it over and over, and it's, by the way, not all that bad if you start thinking about it. If it's 50 years, you basically, the discount for that is about 7-8%. So if you add another $10 to a $100 certificate, you actually would be there. But you now level the playing field for everybody, and I think that would be a very important. Can we do that? Let me ask the question this way to all of you.
I don't think that's the path to go, because if you go on holiday and you book your hotel, you have 5 stars with different prices. For me, the route is that you need all the solutions, but you can have different pricing elements to the various standards. That's how I would expect it to go.
In the voluntary market, yes, but once you go beyond that, you actually didn't put it away if it's 20 years.
Yeah.
So pay for that difference. Your hotel has to have a minimum standard.
And to that I agree, and that is in the baseline and in the whole MRV. I very much agree to that. Yeah.
I think for me, the best way I can answer that is really to talk about the certification process itself, right? There's something called the Storage Resources Management System, which I had mentioned before. It's based on the Petroleum Resource Management System. That's basically a third-party validation that you have that capacity when they do that injection. It's very important that we have that certification because that's going to be our accounting system. It's not going to be perfect, at least not initially, but maybe that's a basis. You know, there's at least some rigorous way of doing that accounting that might play into what you're describing. But again, from the DOE's perspective, and our program perspective, we want to be able to develop those tools and those accounting so that if there ever were to be storage certification, there might be a process in place and there might be third-party businesses that actually do that certification.
Just to layer on the buyer perspective, because I see all kinds of credits and all kinds of methodologies, and they're not the same. And so it's not about holding them to the exact same standard. It's about holding them to a bar that can be equilibrated across all of the different verticals so that you have a set level of reliance. They're all going to meet that performance-based standard differently and using different vehicles to get there. You know, mineralization will be one way, and it's reacted, it's 2 years. We know where it is, there's ways to do that. But there are other tools like buffer pools and insurance and uncertainty factors and all of those things, and there's different frameworks that you can use for the other solution sets that can get you there where you can have a reliable credit, but we have to get there. And so we need a lot more information and development of these MRV frameworks to get there. But to your point, we need all the solutions. Mineralization has a very clear pathway to permanence. Others are going to have to be creative in a responsible way.
Thank you very much to the panel. Let's give them a hand. So the last panel of the day, moderated by Kim Ossie van Brecht from Planet Forward. Welcome, and we'll just get you mic'd up, and I'll use the opportunity to tell you a bit about what happens later today. So at 3 o'clock, we will meet in front of Harpa. There are 3 buses waiting for us to take us to the field trip, to the Carbfix operation sites, and the Climeworks Orca plant. There will be guides telling you everything you need to know about the sites on the way there. At 5:30, there will be a reception And then you will be transported back to Harpa again with 30-minute intervals. So the first bus leaves at 8 o'clock and the last one at 9. And there's no need for specific hiking boots or any sort of gear. So in this panel, we are going to be discussing environmental justice and social impacts of mineralization projects. What does responsible deployment look like?
Welcome.
Hi, everyone. How are you today?
Thank you.
Woohoo! So I'm really happy to be here. My name is Kim O.C. Van Brecht. I'm the Associate Director of a project called Planet Forward. It's based at George Washington University. We teach a diverse group of college students from around the world about science communication and environmental journalism. And I was here in Iceland this summer, and that's how we met up with Carbfix, and they invited me to come here and lead this panel. So now I'll let the panelists introduce themselves. Caleb?
Sure. Good morning, everybody. My name is Caleb Dog Eagle. I'm an enrolled citizen of the Standing Rock Sioux tribe in North and South Dakota, and I currently serve as the Solicitor General for the Mille Lacs Band of Ojibwe, which is situated in Minnesota. Happy to be here. I look forward to our discussion today, and yeah, thank you.
Hi everyone, my name is Finnur. I am the chairperson of the Icelandic Young Environmentalist Association. So I identify as a climate activist and have been active in the climate activist movement for about 3 to 4 years now, and have delved into the global but also local sort of discussions on climate action broadly, and I've got the opportunity to engage with Carbfix in recent years, which is very nice, and look forward to the discussion.
Good morning, everyone. My name is Bill Handirango. I'm the CEO of a company called Great Carbon Barley, based in Nairobi, Kenya. We are a project development company and systems integrator that's looking to develop hubs in the East African Rift Valley focused on direct air capture and storage.
Hi, everyone. I'm Anastasia O'Rourke. I am Managing Director of the Yale University Carbon Containment Lab. We're a second there. we're a non-profit part of Yale University. We're working on many projects to do with carbon dioxide removal, including 2 on mineralization, one ex situ and one in situ. So we've taken a real interest in the Pacific Northwest and the Columbia River Basalt Group, which you've heard lots about already. And we've been working on doing feasibility assessments for really a region-wide system sort of view of what it would take long-term to develop this responsibly as a resource for carbon storage, as well as carbon management up the chain. And that has included a lot of engagement with particularly 2 tribal nations who are the original owners and stewards of this region, as well as looking at all sorts of other sort of historical issues and environmental justice issues in this particular region. So bring that perspective to this panel.
Hello, my name is Hólmfríður Sigurðardóttir, and you can call me Frida. And I am the head of the environmental affairs at Reykjavik Energy. And I was the first project manager of Carbfix in the early years, long time ago, Siggy.
All right, great. So the college students that I work with at my project, they're very interested in environmental justice, and that's obviously in the title of our panel. But as we discussed yesterday, that seems to be a very American term. So I was hoping, Anastasia, you could give us a little definition of that, because I know you have taught and have given that.
So I also teach at Yale, and our students are all very interested in environmental justice, in particular in this new emerging field of carbon management. And it's fun to explore that topic a bit. We think about it really as it's fairly basic. It's community-centered sort of project development, if you like, from our point of view. It can be very practical. I think what people like talking about is really recognising past harms and past problems in certain regions, and really thinking about things like racism that have occurred and who's been really disproportionately affected by many large infrastructure projects over the years. So there's a sort of an aspect of this, of recognition, and then restoration, or thinking about what can we then do about it looking forward. And following from that sort of engagement, so both understanding and listening and really finding out what happened and why, and how people view their area, what they want to happen in the future. And so there's a lot of technical terms out there for different types of justice. I don't think we need to get into it. But from a sort of very, baseline level, it's there's a lot of people in these regions, and they have a lot of opinions, and they're not always converging on the same opinion. And it's good to really spend the time to both research and listen and engage a long time ahead of any particular proposal coming in. So that's a bit of an overview, that just to set us off on our path for discussion today.
Thank you. As several speakers have said over the past day, we need to do everything, everywhere, all at once. Obviously, carbon capture is a big part of that. But as we move toward more responsible deployment of the mineralization technologies that we've been hearing about, how do we make this as equitable and inclusive as possible, and ensure that this includes areas of the global south? Frida, you want to start?
Yes, I would like to start. And thinking about the early days of Carbfix, well, what was it based on? Sigge mentioned in his speech yesterday, we were building up the capacity, the knowledge of young people to take the knowledge further into the future, and some of them are here. And definitely an international collaboration. We had the guys from Columbia University, people from Andreasen in Toulouse in France, and at the University of Iceland, and then the company Reykjavik Energy. And we should have access to the technology. And well, as I mentioned earlier, this was a fundamental baseline for the project. And actually, we were in the middle of the financial crisis when we started. So you might say that Iceland and the company was in difficulties, but still the project survived. And I believe that is because of the group, the variety of the group that was participating. And well, only 15 years later, well, I was very happy to see yesterday in Sandra's presentation that now Carbfix is already such a young company, is approaching companies in Africa and companies in Asia. And hopefully they will manage to do that in a way that, so that Carbfix can help the South help themselves. So, yeah, that's my view on it, or take on it.
Thank you. I'll take this off, from an interesting perspective. If you Google right now, sort of search the top 10 countries in geothermal production, surprisingly or unsurprisingly, Kenya is actually number 7 or 8, depending on the ranking. And we have a ton of geothermal. We're very green grid, so about 93% of our grid is green and driven by geothermal production. And last week, the president made a commitment to making sure that we have 100% renewable energy on our grid by 2030, again, driven by geothermal. And the reason I'm bringing this up is that's partly been, of course, due to policy development and enabling environment, but has actually been driven a lot by collaborations with Iceland. So we have a lot of our geothermal engineers that are trained here, or lots of collaborations over the years that have taken place to really ensure that knowledge sharing and all that is happening to the point where we've now become experts and are starting to develop the same technology across the region. And so if we use that as a corollary, I would like us to think about what that could happen if we did the same thing with sequestration at these very nascent stages. So we're still at this place where it's a very foundational conversation, but if you think about what's happened over the last 2 days on these conversations, a lot of it has been geared to what's happening in Europe, what's happening in North America. And it's okay because this is just the beginning, so we're not blaming anyone, but we're saying, how do we make sure that the Global South is part of these conversations and not just from, we'll involve you later, or how do we make sure that we bring the Global South in these conversations at this point? And it's this idea of technology transfer, it's this idea of looking at these countries and saying, wait, what other places can we look at mineralization? What does it take to do investments in those countries? Part of what we're doing at Great Carbon Valley is we are trying to develop or to drive the conversation and say it's possible for Africa to be a big provider of solutions to the decarbonization efforts. We have lots of renewable energy, we have lots of basaltic formations and talent and all these kinds of things. And so the question is, how do we bring these questions or these factors to these conversations and saying, as we are looking at different sites, as we're looking at policy, as we're looking at regulation standards, how do we make sure that these countries are involved in those conversations, and not just from a token perspective, but from an actual technology transfer and collaboration perspective?
So as a follow-up for that, what do you see as like the major obstacles, and like what are some potential solutions? And that's for anyone to answer that. Go ahead if you have ideas.
Well, I could start shortly. Well, definitely looking at the situation in the world today, well, politics and corruption is definitely an obstacle. And we don't have to look far away back. For example, the COVID pandemic and the war in Ukraine. All of this is affecting poor people, poor societies. And I can also mention the terrible disaster in Libya this week. How is that the connection to climate change there? Well, I find it so important, and we found it in the Carbfix project from the start, that making a project come true like this, where very few people believed in, it's so important to, when doing that, when working on your projects today, to take into account how CCS or other projects think about poor people. We even mentioned earlier drinking water. We need to think about that. The protection of biodiversity. Speaking to people, inspiring people. Me and Siggi started in the Carbfix project by going on a road trip, I call it. Talking to people, talking to the municipalities, talking to the environmental agency, talking to the ministry. And this is just what you do at home, you know. You need to talk to the family. And you need to ask for cooperation and collaboration and disseminating knowledge.
Mm-hmm.
Take it away.
Yeah, perhaps to add, I think it's, first of all, really important that we have this discussion at this summit. I'm really glad that this topic is being brought up, the environmental justice topic. And I think one of the biggest challenges is what you've been mentioning, the bringing the correct voices to the decision-making table, having the most marginalized actors in society, both in our local communities, but also in a global sense, taking part in the decisions and often leading the decisions, because we will see different opinions and views on how to use this technology. And at the center of environmental justice is doing the right thing for the most marginalized people who have done the least to create the problem we're trying to solve. So I think really having a mindset shift of bringing the right people to the decision-making table, both in the private sector and the public sector, both when making business decisions and when creating the public regulatory framework is a really essential thing to do. And having this conversation is essential. And I think these kinds of conversations need to be brought more into these kinds of forums, and especially in the lead up to COP28, which will be happening later this year. Having these sorts of discussions more often is essential.
Just real quick, I think there's something to be said for a narrative shift, and I think it happens both ways. There's, when you ask people, for example, do you think about the global south, or there's whatever the narrative is in terms of what's possible, or that's not even something that comes to the table. But even on the flip side, even in the global south, there's a starting to have these conversations and making sure that people are aware that this is happening. There's conversations happening about mineralization at a global level. How do we make sure you're at the table, and how do you make sure that you're represented correctly, you have the right voices, and making sure they have the right information? Because sometimes if we're not careful, what tends to happen in some of these conversations, it tends to be antagonistic, and it's them versus us. But how do we bring people together to realize this is actually a global problem? It's affecting every one of us. We all need to come together and actually solve the problem together. But at the same time, there's an opportunity here that communities can actually benefit, because if there's going to be $1 trillion, as we had yesterday, going into carbon management, there is a chance for some of this funding to flow to some of these spaces, create jobs, create opportunities, create livelihoods. So again, there's also a way around how we communicate, how we create awareness in a way that is both empowering, but also creates collaborative conversations rather than fights and antagonism, as it were.
Go ahead.
So a couple of things we've experienced in some of these engagements. One is that some of these communities are being asked to engage a lot in a lot of different projects, particularly sort of large-scale renewables and other projects in the region, not only the ones that we're talking about. And there's a real fatigue of being over-engaged, actually, and a real lack of capacity in these groups. They just don't have the people and the time to be good counterparties. And so we've got to think of creative ways of giving them resources, literally funding to come to meetings, to read things, to engage, just as a consultant would or someone else would. So that's one thing to think about, just from a very practical point of view, is we're asking a lot of these different groups, and I would love to hear your perspective on that, actually.
Yeah, thank you. I have a lot to say on it, and unfortunately not enough time to do it. But I will do my best here. I heard funding for community engagement and being worn down by so much engagement. It's a double-edged sword. It's good. You want to be at the table. You want to be part of the conversation. You should be a part of the conversation. From a perspective of Indian tribe or indigenous peoples throughout the globe, or marginalized folks throughout the globe, or ones that haven't been included as much thus far in the conversation from the global south. Just recently we had in the States the Department of Energy, along with the Department of Defense, fund north of $150 million for projects that aren't even approved yet. And part of that funding is for community engagement. So in the United States, we have our government funding companies to engage with communities, but they're leaving the communities out. They're not funding the communities to engage, to get the capacity that you mentioned, to be able to advocate for their own rights. So there's still unbalance in the scales there. And that's just one example. I could go on with many more. And I think another piece of that is corporate social responsibility. That was brought up in the previous panel. I think it's the ethical and right thing to do for corporations and businesses to adhere to the rule of law, and to not assume that governments might be doing that themselves, or fulfilling what other obligations they may have to different peoples within their territories. That's another important thing. So I think community engagement, directly getting in touch with those in the community, and not just individuals. From my perspective, I work for the Mille Lacs Band, excuse me, of Ojibwe. We're a government. It's a government-to-government relationship. It's not just a normal community where it's just a town, right? I mean, we have different rights that afford us, should afford us more a part of the conversation than we're at so far. So I don't want to dominate the conversation here. Let's keep going. I'll chime in, and there's much more to say.
Thank you so much. So I know one of the concerns at least one of the many concerns in the U.S., is the close ties of these projects to the oil and gas industry, especially among young people. So my question is, and the reason is because obviously they think that it will perpetuate just the ability for companies to continue with their emissions spewing habits rather than innovating away from that. So how else might we equitably fund carbon reduction? I've stumped them.
I think I can go ahead. From where I sit and from a Kenyan perspective, African perspective, and from what we're trying to push both in different pieces of work that I'm doing, the reason why that is important is we look at it from an opportunity narrative, which is saying that there's lots of funding that's going into carbon markets, into carbon credits. The question is, who's the money going to? Are people aware how the projects are developed? Are they aware how credits are, who's giving these credits? Who's doing the MRV? And so some of the things that you'll hear on my side of the world is people saying, oh, it's global north companies that come in, do these projects and make all the money, and they're making money off of our lands, and how are we benefiting? And unfortunately, what that's leading to is bad policy, because people are sort of trying to push back and saying, okay, we don't want guys developing this, we need to get paid, and then they start imposing really horrible taxes and just things that would, essentially going to stifle the development of carbon markets. And I think the more transparency and the more awareness we have, that I think will actually drive a lot of this, where people feel like we know what carbon credits are, we know how the market we know how the markets work, we know how we can participate, and anyone can participate and actually get get paid fairly, and you don't have to be from some special company or some special country to make the money, but to a large extent, the more we can make the markets a lot more open, a lot more equitable, and a lot more transparent, I think that will actually drive to some, will actually begin to solve for some of these issues.
Yeah, I do. Just connecting back to the last panel a little bit, I do think there's opportunity for buyers of carbon credits to ask more questions of how the financial benefits are being distributed, to your point exactly. Who's really ultimately getting the benefit? And how can we make sure that that's transparent and accountable in a way that goes above and beyond the sort of bare minimum? So there's some interesting models being developed for this that connect back to the Sustainable Development Goals and so on, but I think we've got a long way to go of sort of standardizing those sorts of requirements and really making it this sort of transparent system that we all hope for, because it's quite a complex market, and it takes a while to learn what's really going on in carbon markets in general.
Mm-hmm.
Yeah. I think the buyers asking questions and the transparency that you're both mentioning is super essential, because of course we have to make sure that the use of this important technology is just one of the tools in the toolbox. We have to make sure that it doesn't distract from deep and rapid emission reductions at the same time. And that has to come from two sides, in my opinion. It has to come from, of course, the regulatory side to make sure that there is transparency from the actors on the ground. But it also has to come from those who are engaging with CCS themselves. It has to be through a shift in the narrative of the actors who are engaging with CCS. And Carbfix has done this quite well. As was said in the previous panel, it's not the silver bullet, but it's one of the important tools. And I think if we manage to get all the actors who are in this sector aligned with this narrative, we'll make sure that this technology doesn't distract from the other things that have to be done at the same time.
And I think equity is certainly a good target and goal to be looking towards. And I just want to, highlight, I don't want to brush past the importance of greenwashing. I mean, CCS is important, right? It's important for all of us. We should be doing it. And it's one tool in the toolkit that we should be using. But we want to make sure that the projects that the carbon is coming from are still being held to standards. We want them to stand alone. We don't want previous bad actors or polluters to then just kind of not move towards more sustainable mechanisms because they can do carbon capture. I mean, that's really something, we don't want to lose sight of that, right? Our goal here is to reduce our carbon output and to move towards more renewable and sustainable practices.
And if I would like to touch upon rules and regulations. They are so important, and as we heard yesterday and earlier today, it needs to be regulated, what we are doing, and other projects like other projects than CCS and mineralization. And well, working at a company, a utility and energy company, you know, and a big company in Iceland matters, we need to take the lawyers on board. And they understand the law. And we need to bring the lawyers to the scientists so they can take the discussion, actually, how are we interpreting the law and the regulation? And it's good.
There's some of the risks that we heard from people we've been talking to that they're really worried about. The risks are not subsurface. They kind of actually trust that the CO2 is going to stay down there. They really like the permanence of the mineralization process. They're more concerned with the moral hazard question of, okay, who's not doing something because you're doing this? They're also concerned about other issues which have little to do, in theory, with the carbon management. We actually think they're connected, but in the Pacific Northwest, we have a lot of wildfires, and this is actually really what they're concerned about right now. So we're thinking about connecting the dots through BECCS and other sort of bioenergy systems here to address both of those issues. But that's going to take a long time, and we can't overpromise yet because there's still quite a lot of technology development to do. They're concerned about surface infrastructure. They're concerned that you're going to be adding a lot of trucks to our roads, and those roads are already not terribly safe at certain times of year where there's a lot of harvests. And so, again, very practical issues. They get right away that this is not just about the hole in the ground. This is about how do you get the CO2 from other parts to this place, and that's what they're more worried about. And I think there's, you know, pipelines in the US has become a real sort of touch point issue. And I don't think we've had much of a dialogue in this community about how we're going to get the CO2 from here to there and do that responsibly in a way that people are comfortable with. And so I see that on the horizon as a big topic that we're going to need to face. And we certainly hear that from our students, very nervous and concerned about pipelines in particular. That's going to vary a lot compared to here. And you see these hot water pipelines everywhere, and that seems to be less of a concern.
Well, yes. I want to touch upon this because, you know, being in the environmental sector for decades, you know, people have been worried about, you know, pipelines. And these are the same issues that people are worried about today as they were 30 years ago. Why are people still worrying? What have we not been doing properly as companies? So we have not been able to getting the message across that if you are going to pump hot water out of the ground or injecting CO2 into the ground, it needs infrastructure. But you can talk and you can talk and you can talk, but the phrase trust has something to do with this too. And well, it helped us in the Carbfix project in the beginning that we were connected to a green geothermal producer, green energy. It was not the oil and gas industry. But still, geothermal can be an obstacle, you know, we can discuss a lot about it in Iceland. But we have not been able to get the message across so that people, and then I'm also thinking about globally.
Sounds like a communication projects.
And we fear, you know, the projects that have not succeeded.
All right, we only have a couple minutes left. We are running very short on time, so I have two more questions, and one I know that Caleb would like to talk about especially. Because a lot of the mineralization projects we've heard about have been on indigenous lands. We have our lawyer expert here, and also Anastasia also has been working in a project that's in the same area. So I want to know, how should we navigate this with both respect and equity in mind?
Well, it was pointed out also on the previous panel just how complex it is, legally speaking, particularly in the United States. You have federal laws, you have state laws, you have local laws. One that I haven't heard, unfortunately, mentioned yet, but I'm going to mention now is tribal laws, which is one of the most important things from my employer's perspective and my personal perspective as an Indigenous person from the United States. The UN Declaration on the Rights of Indigenous Peoples has so many of these provisions in them, protecting our land, resources, territories, our right to self-determination, and a lot of those legal frameworks are within United States law. And I don't think a lot of companies realize the complexities of the American legal system. Getting back to the Declaration on the Rights of Indigenous Peoples, FPIC, free, prior, and informed consent, is huge. You have the community engagement built right into it. It's free. They're free to engage. It's before anything happens, the prior there, so before the train has left the station. It's informed, where you're not hiding the ball on information. You're transparent in your dealings with them. And consent, that they agree with it. Consultation is required in a lot of things in federal law. Thankfully, we want to be part of the dialogue. We should be legally, morally, ethically part of the dialogue. And it's important that we're at the table and part of the conversation. Consultation is not consent. You're not just checking a box. We talk to this community, we talk to this indigenous group, we talk to this tribe. It needs to be meaningful, and consent needs to be got without any sort of coercion. You know, I'm going to build you a playground, and I'm going to build you a school, but we're going to build this big mine that's going to affect you for decades, centuries. So I could go on, but I think that covers the very basic level of it. I'm happy to talk with anyone outside the panel.
Do you want to just touch on how you were talking about how there's a lot of go-between, and their indigenous lands, or people on indigenous lands especially, are sort of overwhelmed?
Yeah, I mean, it's true that all of the great resources that have been put into things like community benefits plans and Justice 40 initiatives and others coming through the federal government. There's also state requirements that are very similar, and then all sorts of just best practices for engagement. And what we're trying to do in our project is line them all up so that we don't overwhelm and do it in a really sort of responsible way, as well as giving that capacity to different groups to participate. But yeah, in general, people have been really open, which is wonderful, and ready to learn, a little skeptical at times, and not everyone's the same, and there's factions and there's different politics going on. So it's a process. It's also about doing it, you know, over time and building trust, and not a one-off kind of event. So certainly building trust is not easy, and easy to lose as well. So I'm sure in communities here as well, and where you're working, it's much the same.
All right, well, we are definitely over time. I have one last quick question for everyone. Please answer it as quickly as possible. So what's the one thing that you think needs to happen to make carbon reduction efforts equitable? Go ahead.
Well, I was actually going to talk about a fair carbon pricing system, but after the talks this morning and in the panel, inspire. Please inspire.
Yeah, I actually like that. I will say we need to show and not tell. There's a delicate balance of doing that, but I think what Carbfix has achieved here is really phenomenal, in part because you learned by doing, you got it done, and you're now able to share with everyone that experience and do so in a way that is inspiring. We think piloting and smaller scale is really helpful to get things going, so pilots.
I agree with everything, but I'd add this idea of just adding a few more people in the conversations. And so as you're thinking about these projects and the different technologies, the question is, what other countries or what other geographies should we be considering? And so even just querying and asking that question will lead to vastly different outcomes than just sort of working in silos and not necessarily bringing that into consideration. And in many ways, at least for me, the way I think about this is, yes, there's a place for donations and grants and concessions that need to happen in some of these countries. But in a lot of ways, I mean, part of what we're driving is, can we see investments happening on the same level, or at least on the same consideration as is happening in the global north? And so if you're considering a place to sort of put in a project, can you think about countries in the global south and sort of evaluate them on the same consideration? I think we'll begin to see some level of equitability coming into play.
Yeah, I think I would say systems thinking is one of the core elements that are largely missing from the current conversation around mineralization. We need to realize that the phasing out of environmentally harmful practices isn't only about greenhouse gas emissions, it's also about ecosystems, it's about societies and benefiting society as a whole. So I'd say thinking more in systems and about the consequences of our sometimes very narrow mindset of focusing only on carbon is essential.
Just two quick things. It's different for something to be done to you than being done with you. And I think community engagement on whatever level it is the important piece for overcoming that hurdle. And then as far as environmental justice, I do want to mention just a developing area where the Juerg tribe in Northern California has given the Klamath River rights as a person in the law. In New Zealand, I'll probably not pronounce this correctly, but the Wanganui River has been given rights as a person. And in Canada, the Magpie River has been given rights as a person. So that's a new way to think about environmental justice and how we're treating the earth that provides everything for us.
That's great. Yeah. Thank you, guys. Thank you.
Great final words. We want to invite two questions. One up there and one here behind that thing. We'll start up there.
Good job. I enjoyed your comments.
Thank you for the wonderful panel discussion. My name is Peter Kang from University of Minnesota, and my question is about how to ensure environmental justice from early R&D stage. So I'm part of DOE EOFRC, where we focus on basic science. But even for basic science, I think, especially in terms of mineralization, it's very important to think about environmental justice from very early R&D stage. And one naive idea that I can think of is, for example, involving tribal students as graduate students for the center project. But that's just one basic idea, and I just want to hear some various perspectives from you, how to ensure environmental justice from early R&D stage.
Sure. Well, that's a really good question, something I'm really excited about, because I think about Africa again, lots of young people, lots of talent, and to the extent that we can actually begin to create an ecosystem of STEM, graduates or just engineers and scientists involved in R&D would actually be really good. And so to what extent are we seeing grants focusing just on specific regions versus opening up the grants to multiple countries? Because the scientists would like to apply for these grants and be part of the R&D. And the reason why that's actually really important is if you have this R&D being done by people from those countries, then you don't necessarily have to, I'm being simplistic here, you don't have necessarily to worry about environmental justice or equitability later on, because ideally they would incorporate that in their own research. Because if I'm doing research in my own country, I'll probably take care of things that someone else might not even think about, because it's my own country. I understand the nuances, I understand the context, and so the more we have a lot more research being done by folks across the world rather than just very specific areas, I think that will actually go a really long way, both in creating more opportunities and ensuring that these brilliant minds are utilized in these early stages of R&D, but at the same time, I think they will incorporate and bring in ways of thinking, especially around justice, that probably wouldn't have come into place in the first place.
Yeah, perhaps I think the idea of path dependency is important, and that ties in with the systems thinking thing I was saying earlier. When you're starting something new, you have endless possibilities, but the farther you progress, the more limited you become. So if you make sure at the beginning to take into all the environmental, so non-climate environmental ideas, making sure that you think of the wider implications of the thing you're working on, both with regards to societies and wider environmental impact, I think that's really essential in addition to the technical aspects.
Thank you very much. And then we have one here, second row.
Thank you very much. Stuart Coulthillan from the University of Edinburgh. So we're seeing across the globe quite a different variation in how the multinational hydrocarbon companies are starting to either tackle or ignore the climate crisis, depending on which ones you might want to think of. And given what we've heard so far about what's urgently needed in this field, which is to scale things up as quickly as possible, how does the panel think that investment from some of the maybe more proactive multinational energy companies, as they may see themselves, you can debate that a little, could be handled, or how do you think that might go down?
This is a difficult question. I'm not going to start.
You just did.
Finito.
Yeah, I think it's essential that, as I mentioned earlier, that the CCS technologies don't distract or deter actors from rapidly reducing their emissions. So I think the prerequisite for accepting that these companies are investing in CCS is that they properly commit to reduce their own emissions and shift completely away from their harmful fossil fuel practices. And I think until we see those commitments, which in almost all cases we haven't seen yet, then they're sideline investments of fractions of percentages to these kinds of technologies are pretty much unacceptable, I'd say.
There's something to be said, again, when you look at some of the global south markets where in many ways industrialization hasn't happened, but it will happen, and there's going to be investments happening. I think it was yesterday we were talking about 1 billion people have pretty much created the problem we have. We have 6 billion people that are going to be demanding a similar lifestyle. So we're going to be having requests for energy and construction and all these kinds of things that we've seen happen. And so the question becomes, how do you create investments? Because people will demand those lifestyles. So how do we make sure that from the word go, things are done in a different way? And so I'd love to be able to see more industrialization happening in Africa or in some of these countries, but from a climate positive growth perspective, which means that we are driving industry, but we're making sure that we are incorporating standards of whether it's clean energy or things around sequestration, etc. So I think there's something to be said around how we begin to create new standards for industry and making sure that that becomes the norm and finding ways to incentivize that. So are we, how do we make sure we're not penalizing companies that do the right thing and making sure that we are taxing or finding a way to just incentivize good behavior and discourage bad behavior, as it were. But I think there's a really good opportunity here for us to build clean industry in some of these areas from the word go, rather than trying to make it to clean after we build dirty industry and then coming back and saying, oh, we need to find a way to, to clean our cement industries or our power sources. We actually have a chance to do it in a clean way from the word go in some of these markets.
Well, thank you very much to the panel. And before we ask Edda Ardóttir to come and close this part of the program, Ólafur Teitur is going to review the statement that you had an opportunity to comment on yesterday.
Thank you, Vala. Yes, as you are probably all aware, we felt that it would be a great missed opportunity not to have a tangible outcome from this effort of 2 days of discussing these matters of subsurface mineralization. We feel that it will be a great outcome of the summit to have a statement on these issues to be published following the summit. We have had word, in fact, from some policymakers that they feel that this would be a very helpful tool for them also to raise awareness on the advantages and even existence, in some cases, of subsurface mineralization. So we feel that this is an effort very much worthwhile. We received yesterday about 30 comments on the proposed draft that we sent you and made available to you. About half of the comments were, this is perfect, this is great, I'm signing up. So that was great. The other half of the comments were suggesting some changes to the text, and I believe it can be summarized as two kinds of responses. On the one hand, there was the request or ambition to have the text bolder and stronger language. On the other hand, there was also a corresponding view that we should remain grounded and humble. And I think both of those concerns are quite legitimate, so we have tried to balance those out, and we're going to show you what changes we are making to the statement as a result of those very helpful comments. So thank you all for submitting those. We will be making the revised statement available to you and asking you to indicate your support, hopefully, for being mentioned as a signatory to the statement, requiring your name, and then as an optional to also mention your profession or affiliation, so that you will be able to sign it virtually in either an individual or professional capacity. We do know that some people have said that they would need more time to review internally. That's quite welcome. You can join the statement at any time, but we are aiming to publish it on Monday. So I would say midnight Sunday evening, GMT, would be a great time to have your willingness expressed as to whether you would like to sign the statement. And for this to be a really valuable tool, we of course need to have signatories to the statement. So if we review paragraph by paragraph what we are suggesting, if I can have the first slide on minor issue, instead of saying it's signed at the summit, it will be issued following the summit. So that is a quite simple change. Am I controlling this? Yes, I am. Excellent. I like to be in control. Here we have a comment that serves a notion that we should reduce the reliance on the term storage. There was some willingness expressed to eliminate it altogether. I do feel that we should, for the time being at least, use terminology that is widely used and recognized and accepted, even though storage has isn't a perfect term. So there we would say we agree that subsurface mineralization of CO2 and the points then follow doesn't really make a material change to the meaning. This paragraph did not receive any comment at all, so we will consider it perfect, except that the two should be in a whatever you call it. We will make sure to address that issue, so be patient. I think it was a legitimate comment also that we should strike this part of the sentence that subsurface mineralization has passed the stage of being a theoretical possibility, because the legitimate comment was made that this might be interpreted as meaning that there is no further R&D necessary, that we are, home free and no research necessary going forward. So I think the statement is equally strong by striking that part of the statement. We are replacing the word durable with the word permanent here, not to be kind of like it was said yesterday, washing machines are durable, but rocks are permanent, and adding the word carbon to before the word removals. And then there was some that expressed confusion about what the 99% in the sentence was referring to. It is referring to the fact that this natural carbon, or that rocks rather, are by far the largest carbon reservoir containing more than 99% of the Earth's carbon. So this is just to clarify that fact, and then enhances and accelerates instead of utilizes. This is really just improved language, I would say, came as a suggestion. Instead of enables storage in areas previously not considered feasible, the wording is feasible in geographies that are not otherwise well served by carbon sinks. So it's just more elegantly worded, I would say. This change here, proposed change, is to address comments that we should make it more clear that we are must not reduce the focus on other efforts, other climate action that is necessary. So we feel we have made the wording stronger in that regard by saying that it is necessary on a large scale to reach the world's climate targets, complementing other mitigation efforts that must also be rigorously pursued. And this it continues to say, with due consideration to the same robust environmental, social, and quality assurances that must be applied to all mitigating approaches. We feel that also addresses some comments that, or one comment that said we should address specifically the risks of subsurface mineralization. We don't feel we need to go into them individually, but that this statement serves as a reminder of that we need robust environmental assurances, of course. Two comments suggested that we strike the word separate because it was thought that it might imply that mineralization is asking for relaxed requirements in some way. We don't want to give that impression at all. So to reduce the risk of that understanding or reading of the text, we agree that it's fine to strike that, but we do feel that the statement stands that mineralization, subsurface mineralization, should be given attention and consideration as a distinct approach. And that stems from the fact that it is quite often confused or lumped in with more traditional methods that have different qualities and requirements associated with them. So these are the changes that we have highlighted here individually. So this is what the statement looks like after all of these changes. I won't read it through, but you can see it on the screen, and we will be making this available in the same manner as before, sending you a link to an online form containing this text. So we will publish it on the app and in an email to every registered participant. And then you are able, and we do encourage you, to sign the statement and therefore thus become a part of this outcome of the summit that we hope you will see fit to support. One question? Yes.
Susan Stipp, the Danish Technical University. We want this statement to be respected and honored, and that means it needs to be 100% correct. I don't know the numbers, perhaps as well as the rest of you, but is 99% of the Earth's carbon really in rocks? Because there's a huge reservoir in the oceans. Is that 99% correct?
Something for the geologists to address.
It is more than 99%.
More than 99%. So it is definitely on the conservative side then. We could add conservative estimates. No, not to make too light of the matter, but we thank you for the question, and we do encourage you to make sure that we have a solid, rock solid statement. So very much appreciate the comment. So with that, we will leave this section. Hopefully we will have as many signatories as possible to make this output of the summit as effective a tool to raise awareness as is possible. Thank you so much for that. And Edda Aradóttir, please.
Thank you, everyone. As good we were with staying on time yesterday, not as good today. So I am aware that you are getting hungry, want to head out for lunch. I'm going to keep this very short. Just want to thank you all for your participation. We are at the end of the online part of the summit. So a very heartfelt thank you to all of our online guests. I've enjoyed watching the presentations, the dialogues in the panels immensely, and I hope that applies to all of you, both in the room as well as online, and that you feel that the summit has given you the value that you hope to get out of it, both project, scientific, policy-wise, getting sort of the latest information of what is happening in different parts of the world, but also developing new partnership, nurturing existing partnerships, because it's very clear that without strong partners and collaboration, we are that much more unlikely to meet our goals. So thank you for the time being. For those of you in the room, and thank you again to those of you online. For the field trip, we, as Vala already said, we will have buses leaving at 3 o'clock in front of Harpa, visiting our injection site at Helliseiði, the Orca plant as well, and then a fun and happy reception at the plant. So looking forward to seeing you there. But thank you for the time being.